Test.
Where is the on button for this as well? It's the little red one.
Yeah, you just press it until it goes off.
Good morning, everyone. We have a small but perfectly formed audience this morning for our student prize-winning presentation. So another congratulations to Max for that. And now you can all make your own judgments on his work as well. So Max Pieperkorten, who is working with Anna Jordanis and Dan Brown at 3 universities, in fact. Okay. Leiden, Waterloo, and Kent, with Tom Carlholden, yes. Okay, so with that, I will pass you over to Max.
All right. All right. Yeah. Hello. My name is Max. And yeah, this is work with my friend Tom, who is at Leiden, and my supervisors, Dan and Anna. And I guess I want to start saying evaluating LLMs is really, really hard. And this work mainly evolved out of that sort of experience. So I guess in part I'm presenting this methodology on how we approach actually this simple question here. Is temperature the creativity parameter of large language models? Right. Right. So this question alludes to this claim that if we just adjust this parameter, that we somehow enable more creativity in these models, sort of almost auto magically, if you will. Right. So in popular media, we see all these kinds of claims. It acts as a knob to control how random and creative the output will be, or the temperature parameter is used to control the level of creativity in AI-generated text, and or it might be beneficial, or yeah, I mean, they're all more or less the same. And we also see them in academic papers, actually, not so phrased in the same way, much more carefully, of course, but yeah, it does appear. So this question really sort of begs answering. And yeah, okay, let's first, what is temperature actually? Temperature was part of a Boltzmann machine in the beginning, which was first introduced in 1985, and it's borrowed from physics, actually. So entropy, and in large language models, we find them as a parameter before we softmax to create our probability distribution. It's right up there. And what temperature does is it controls the shape of the distribution. So if we increase the temperature, we see that we sort of flatten the distribution, making it more likely that other tokens will appear as well, and thereby indirectly sort of controlling the randomness in the output. And as we see here on the left, we see that indeed, as we pick a higher temperature value, we see more uncertainty in our output. Right. Okay, so is randomness really all you need? So that would be the consequence if this parameter were actually controlling creativity. And I mean, it's generally well accepted that randomness is not enough, and that you need sufficient knowledge to understand that you have some sense of, is this novel, is this of high quality? And it's recently, I guess, been sort of re-mentioned by Simonton. But, you know, for creativity, we do need variation, and temperature does have an effect on the variation that you can produce with. So just not to completely disregard the claim. But yeah, if it would be the parameter, then you sort of, yeah, does the LLM actually have sufficient knowledge to understand what novelty and quality is? And I think that's unlikely, so to say. All right. So to restate the hypothesis, as temperature increases creativity, the LLMs, as temperature increases, the creativity of the LLM's output also increases. And to spoil the result, we didn't find any compelling evidence, but we do see a weak effect for generating novelty, but only if you draw a limited number of samples. Okay, so right, so how do we go about this? So we want to test this in 3 different ways. We were exploring it from a Boden's exploratory creativity angle, and want to see if there's variation in the output on the lexical and semantic levels. And finally, we have a human evaluation on 4 conditions, which is novelty, typicality, and cohesion and coherence as a sort of form of quality. but I'll explain that more later on. Right, so there's so many things that come into play when you want to evaluate an LLM. There are, I mean, choice of prompt, different hyperparameters, which model which model is best for the task. To approach this question, well, as temperature is one of the first you run into, this is our choice, I guess, here. But to test this, we need some sort of baseline to compare against. We need to say, okay, well, temperature 0 is obviously the departure point. We draw inspiration for this approach from theories from cognitive science, which is prototype theory and exemplar theory. And so just quickly, exemplar theory is whether both theory is of categorization, and exemplar theory is basically you categorize based on previous stimuli you have. So when you think of the concept dog, you see one of the dogs you perhaps have experienced. Whereas in prototype theory, you take all your stimuli and you take features that are present in all of them to form sort of a general concept, if you will. Yeah, we decided to go for exemplar since this temperature 0 story is really a stimuli, and we don't really know if it is actually sort of the average story, if you will. Could be there. I think there's an argument to be made for it, but we decided to go with exemplar. Right. So in this view, we say that every prompt and model has an exemplar. I mean, if you change any of these, you basically change the exemplar as well. So you have to be very precise here and yeah, really stick to those two. And that's our temperature 0 output. So this would allow us to compare as we increase the temperatures from our baseline. Okay. Right. So this paper is really a case study with it's a very simple one. It's just a narrative generation task with a single simple prompt. It's just write a story. And we have done our experiments here on one model, which is Llama 2. The big one, it's instruction tuned. And yeah, we explore our 3 goals in a computational analysis and a human evaluation. All right, so what does our exemplar look like? It's very cliche. It's really not a literary masterpiece, if you will. Yeah, so actually here's the exact prompt we used, and even changing like a new line character there has quite a big effect. And we had to add this part here because Llama 2 does engage in all sorts of social banter, of course. So what would often happen is if you just say write the story, it would start off by saying something like, of course it is, here's a story, or it would say, naturally I can write this, I can do this. And this has an effect on your subsequent story, and we don't want that. We want to, because in the end, when you evaluate something, a human would never look at this sentence and right. So we have to keep that into account. Right. Okay. So first, the computational analysis. Right. Our goal here is twofold. We want to see if there's exploration in the possibility space and want to check if there's diversity or variation in the outputs on the semantic and lexical level. So, all right. Does temperature enable exploration? Right. So here we see our 7 temperature values, and we've projected them using principal component analysis. And as you see here, in the lower temperatures, there's 2 clear clusters that form. And as we increase the temperature, we extend up in the space, and eventually there's lots of stories generated there. I mean, these are only 100 samples, so it's difficult to say if this is actually enough. That's another consideration, but this allowed us to see that there's some movement, but it's probably if you would draw many more samples, it might also happen that in the lower temperatures you can actually get some of these points in the space. Okay, right. So does it allow for more variation? So with the semantic, so we have here the semantic level and the lexical level. For semantics, we took the embeddings of the stories in Llama 2's embedding space and did a pairwise comparison with the temperature 0 story. And what we would have liked to see here, if temperature would allow for more variation, is that we had a little bit more of a linear trend, and that the bars would be, well, I guess the deviation should be small first and then expand. So actually with little temperature, you already get lots of different semantic differences. And the same is visible with the normalized edit distance. Actually, that's a typo. You immediately jump up in variation. So does it allow? It does. I mean, if you add these two together, there's a lot you can do with very little temperature already. So adding more is, I guess, limited in effect. Right. I think a tiny thing to say is you can plot this on a logarithmic scale. So if you take temperatures on a logarithmic scale, you would see more of a linear trend, of course. But this is actually, I guess, more the use case in which we would use these models. Okay, thank you. All right. Then human evaluation. So we used Ritchie's essential properties, not these criteria. And this is, I think, a good approach, is appropriate here because we are evaluating the system by its artifacts and not its process. So we have novelty, typicality, and quality. Right, okay, so in the setup, we had, well, this is more or less the setup. Every participant would get this exemplar and a story of a different temperature, and they are asked to compare them against each other for novelty and typicality. And then for quality, we use cohesion and coherence. There's a subtle difference between the two, and cohesion is really about the objective features in the text. If they align well, if the events and the characters make sense, and if it's grammatically correct. And coherence is really about the mental interpretation of the reader. And I think these two give us a nice sort of proxy for quality because they are both about the interpretation and the actual features in the text. Okay, so we are looking for a significant correlation across these criteria. But first, oh, I'm missing a slide actually. Right, so our experiments, we had 36 participants. They each received 5 stories to evaluate, and each story was evaluated at least 5 times across these criteria, and they were non-experts. One of the difficulties with this prompt is that we are generating really terrible stories. So if you would ask an expert, they would immediately disregard them as very bad. And I mean, with experts, non-experts, it's the average user, I guess. So that's again, we're not really interested in making very good stories. We're interested in seeing an effect on temperature, I guess. Okay, so unfortunately, with non-experts, they use different criteria when they evaluate. So the iterator reliability is a bit short of the acceptable level, but I expected a bit worse, I guess. And in fact, they did report that they used different criteria. So that's, I think, important to note there. Okay, so we have a weak positive effect for novelty and a moderate negative effect for coherence. It's negative because our question was that the lower score means more coherence. So it's actually the opposite. And this indicates a trade-off. And I think we see this in other work as well, that as soon as you increase the temperature, your novelty goes up, but you lose coherence in the text, which makes perfect sense. All right, then finally, there's some work that recently came to our attention. So first is a paper by Antoine and Philippe, who are here as well today, where they actually found a positive correlation for temperature on a divergent association task. And what I want to point out there is that when you're generating artifacts or testing using a psychological test to evaluate the creativity of a large, I think there's maybe this distinctions we should make in the future when we are doing these kinds of experiments. Right, and then secondly, it's a bit of older paper which slipped through went under our radar a little bit, but they actually found that a instruction-tuned model is much less diverse than a base model, and that might influence our work as well. And I think there's some work to be done in sort of recouping some of that lost diversity in there to make at least the use case, the instruction tuned models a bit better. Right, okay, to conclude, we did not find any compelling evidence to say that temperature increases the creativity of large language models. And when we're generating limited number of samples, we do see more variety, but it's hard to say if it really enables a larger access to a larger possibility space. And our observations are that we find this trade-off between novelty and coherence. That's it. Thank you.
So thank you very much, Max. We have time for questions. I'd just like to make a comment, if I may, that I think this work shows that you don't have to do something very big and very complicated to do something really good. That's really elegant. Thank you. So questions.
Thank you, Max. Very nice work. So I was thinking, do you think that there are tasks that can measurably benefit from creativity? One question to ponder. Second question, related, is that it seems to me that temperature, which is related with entropy, increases sort of the randomness, let's say, of the result. You know, it plays with the randomness essentially of the distribution. So could or could not be, as you said, it's not clear in the end if it's related to creativity. Do you think that, depending on the task as well, we could guide during decoding, as you do, the LLM towards a better distribution, which would be more useful for a specific task? Have you ever thought about it?
Guess it's a good question. I mean, we just explore one task here, and it's safe to say that there are probably lots of other tasks that all. Yeah. Okay. So, but yeah, I mean, in the end, it really is a question, which I think is a broader question here: is what do we want from these models and when? When we use them in our daily tasks, so just for general, I don't know, brainstorming then we clearly have a different expectation than when we're generating objects here. Yeah, I mean, different domains are interesting tasks to explore as well. See if this holds. Well, maybe it's. I mean, the training data also really dictates what it can and cannot do. So yeah, I think there's lots of opportunities there.
Thank you. We have time for one more quick question.
So in the example you showed, like there was a girl and there is a woman. Now the character changed, but seems like story stayed the same. Like there's a hidden pet. Is it your observation for other examples too? Like the story structure stays the same?
Yeah, that's a good question, actually. There are many stories that are similar where you actually just only swap out the name, or I mean, I showed the top of the story. Depending on where the first change happens, you can see that the story can change quite drastically if it's in the beginning, but at the end, you do have similar narratives. So I have seen different stories, but yeah, it really depended on where the change happens, and it's more likely if you increase the temperature, of course, that it is actually in the beginning. So
yeah. Thank you.
Yeah.
Okay, then. So I think we should move on. Thank you again very much. Next. And our next speaker is one of the wrinklies from this group, Tony Veal, who is going to be talking about something I have to read, long and complicated, from symbolic caterpillars to stochastic butterflies, case studies in re-implementing creative systems with LLMs. Short titles are good. Tony, the floor is yours.
Hello, everyone. So like a lot of the older members of this community, I've spent many years building symbolic systems. I call them symbolic caterpillars because they have many independent moving parts. They're plodding, they're reliable, they're formulaic, they're predictable, and they produce good, relatively safe outputs which look good if you look at them individually. But if you look at 10, 20, 30 in a row, you begin to see the patterns very quickly. So, but I've always felt that the symbolic way was the way to go. So when the stochastic butterflies flitted into view, I repudiate the idea of them as stochastic parrots. That's a 2021 view, which is ancient in this field. Like everyone else, I think, or like many people here, I was in denial, I was skeptical. I reveled in their shortcomings and so forth. But really, I mean, I watched them eat our lunch, our dinner, our breakfast, our mid-morning snack. But I've come to the conclusion that they're marvelous. They're flawed, they're babies, they're going to grow. We have to adopt them. But it doesn't mean that we have to try out everything that we've built, which is just as well, because I've spent a long time building these things. So this is a case study in re-implementing a symbolic pipeline using LLMs while keeping the shape of the symbolic pipeline and keeping the purpose of the symbolic pipeline, which is to model symbolically a complex creative phenomenon. And in this case, it's comics generation. So really what I want to do is to show how we can, with this case study, keep what is valuable about the symbolic approach while embracing the wonders of the LLM to get more fluency, flexibility, specificity, even originality, all of the dimensions of Guilford's divergence, while also having the control of a symbolic system. There are two case studies in the paper. One of them is empirical and quantified. It's to do with trying to inject humor into the comics. And the other is qualitative. I'm going to focus on the qualitative one here to try to derive some takeaway lessons, but please read the paper for the more quantitative results. Okay, so let me begin by describing the comic system and describing the symbolic pipeline before then talking about the reimplementation. Our system is called Excelsior, and it's a two-stage system. First, it generates the comic as an XML specification in a schema we call comicsML. And then that schema instance is rendered. The schema refers to reusable visual assets, such as poses and backgrounds, and it composes them like dioramas. It composes each panel like a diorama or a Lego scene. Now, we originally, when we embraced LLMs, imagined and experimented with generating the XML in a single bound. That didn't work for a number of reasons, produced very poor results. And that's why we keep the symbolic pipeline, but replace many of the nodes in the pipeline resources. But let me quickly show you the visual assets that we use. We've got about 500 reusable character poses and about 400 reusable backgrounds. Now, I know we could use AI to generate these things. I do not want to do that. It is very easy to build AI systems these days where you do very little of the work and you're essentially an expediter or a Svengali that gets the machine to do everything, and there's nothing of you left in the system. Whatever you say about symbolic systems, there was a lot of us in our systems. And I want to keep it that way. I want the output to contain part of me. I want the system to be part of me. I do not want to replace all of me in the system. So I will continue to keep drawing these resources, and I will rely on the LLM for the textual and plot content of the comic. Now, I should say that the comics are meant to be topical debate comics. They're part of a project in which we're trying to create comics that show people both sides of a topical concern so that echo chambers get disrupted by exposing people to multiple points of view. So they're not so much story comics as debates in comic strip form. Comic strips because comic strips are unthreatening and engaging. Let's take a topical concern, okay? This chap here, world's smartest man-child. And let's see what our symbolic system can do with this topic. First off, what we do with the symbolic system is we generate many candidate hashtags, more than would ever be used, and we go searching for them on Twitter in the last week. And those that we find are attested And then we use those as the basis for a topical comic about Musk this week. Now, the mechanisms that allow us to generate those hashtags also connect to an ontology that allows us to understand the hashtags in terms of sentiment and some basic conceptual structure. So for instance, Musk fail, Saint Musk, MuskCon, we can understand these things because we generated them to begin with. Okay, that's one of the powers of symbolic systems. They can, if you do it right, understand what they generate. Okay, so when we have a conceptualization for each hashtag, we map a selection of hashtags onto comic panels, one panel per hashtag. And we use the symbolic model to decide which poses to use, which backgrounds to use, and what dialogue to put into the balloons. The dialogue is template-based, so it's very stilted, very formulaic. Here's a comic that's generated for Elon Musk. We reuse our scale-extric story generation system to give us two characters to debate the concept of Musk. Here we've got Wolverine and Catwoman. I know they don't exactly look like Hugh Jackman and Halle Berry. We're working with configurable poses, but are not super configurable. Think Lego Hugh Jackman and Lego Halle Berry. Okay, so the two hashtags that form the basis of this comic are fascist Musk versus support Elon. These are genuine tags. They're not my personal opinions, but you probably can guess which side of the debate I lean. Now, the comics are functional, they're effective, they're well-formed comics, but the dialogue is stilted. If you watch one comic, you think, oh, this is quite good. You watch 10 of them, and you say, oh, I see the patterns, I see the recurring tropes, I see the pulleys and wires behind the scenes. It's very dispiriting. Okay, so the comic output is relevant, it's on topic, it's relatively diverse for what you get, but it's stilted, it's formulaic, and it never surprises the creator. And that's another problem with symbolic systems. They rarely surprise the people who build them, except when they accidentally go wrong. And if they go wrong in a fortuitous way, we take credit for the outputs using the ELIZA effect. And if they go wrong in unfortuitous ways, we write papers about that. We really want these things to sparkle and charm every time. I want to be surprised and charmed by the outputs of my system. It's about time that we are, right? So let's embrace the language model while keeping the symbolic pipeline. Okay, let's embrace modern times. We use GPT 3.5 Turbo. Basically, that's the cheapest version of ChatGPT. It's cheapest chips if you're using the API. We find that we don't get better results with GPT-4, so there's no point in paying for what you don't need. Okay, so what we're going to do is replace many of the parts of the symbolic pipeline with prompt-engineered interventions. Now, let's take Mr. Musk again, right? We want semantic representations for our symbolic pipeline, and our LLM can give us semantic representations, because semantic representations, the big cheat in logic is that semantic representations are a form of broken English, right? And it has been since ancient times. Logic, after all, can really ask the language model to give us 10 semantic triples. And we define an example of a semantic triple, okay, one-shot prompting, and we ask for 10 neutral triples to represent Elon Musk. And it's quite good. Here we get the semantic triples. Whenever you ask for n of anything, be sure to ask the LLM to number the outputs. It loses its count very easily if you don't ask it to. But if you do ask it to number its outputs, it's very effective. Also, if you have multiple successive complex prompts, if you number the outputs, it's very easy to align the outputs across prompts. It's a very good tip. Okay, so we get that he founded SpaceX, CEO of Tesla, believes in colonizing Mars, invests in AI, and so on. There's something dubious in there. He's a philanthropist for education initiatives. God knows what that is. But I'm willing to believe it. Now, we can also use the output from the symbolic system as a context for the prompt to support RAG, retrieval augmented generation, so that we can overcome the training horizon of the language model. Here's where the magic happens. We want two opposing points of view, but language models are dreadful at the moment with negation. They treat negation words as words when in fact they have a much more important global function in the sentence. So when you ask it to negate a point of view, you often get a double negation, which is where you're back where you started. Avoid using negation in your prompts. The language model that we're using understands words like irony and cynicism very well. So we go for cynicism. We ask for a benign and a cynical interpretation of each of the semantic triples, and we go one further by turning them into rhyming couplets to take advantage of the Keats heuristic. So the output of the comic feels like a Mad Magazine parody from the 1960s. Okay, so some of the rhymes are quite good. Okay, Elon Musk, Tesla's CEO, making green cars cool. Tesla's CEO just wants to play the fool. Notice there's a call and response structure here that's consistent throughout. That is typical of what you get when you batch your requests to an LLM. If you were to do the request for each panel separately, you'd get a hodgepodge of poetic styles. But when you batch your requests using numbered lists, you get great coherence. Okay, we also need a narrator for the captions. We have a pool of 50 narrators who are all linguistically identifiable through their cadences and their narcissism and so forth. Here's Donald Trump, he's very identifiable. My favorites as narrators for comics are Borat, very charming, very nice, and Jerry Seinfeld. But here's Trump. He makes everything about himself, and the language model gets that wonderfully. They're very good mimics. Mimicry is not parroting. Mimicry involves invention. It's quite a tough thing to do, and the language models are very good at it. Now, we have to map these outputs into rendering decisions. At first, we gave the language model a full inventory of all of the possible poses and backgrounds, and it still hallucinated wildly. So we now give it no background. We simply say, knock yourselves out. Invent poses for the left speaker and the right speaker in the background based on what you've generated for their dialogue. And then we use the vector space model to map those choices onto the available choices. Vector spaces are hugely important if you're going to stitch a language model into a symbolic pipeline. So you absolutely need them because the language model is not going to play ball with you, but you do have to meet it halfway, and the vector spaces allow you to do that. Here's the finished comic. The symbolic component makes some very dubious choices. Here are the two narrators are Dirk Diggler, which you may remember from Boogie Nights, and Lisa Simpson. Okay, just a very unusual pairing. But the poses in the background, and here's the comic. Okay, so let me finish very briefly by just demonstrating the flexibility of the approach. There are 10 lessons, take-home points in the case study, which we dumped into the comics generator, which happily generated comics out of the 10 points in the paper. And here they are very briefly. LLMs can generate formal semantic content too, so you can throw away those ropey old symbolic databases that you rely on without throwing away the symbolic logic that uses them. Batch prompting limits diversity within tasks, but it maximizes it across tasks. Symbolic systems can still generate valuable content for use in prompting the LLM in context for RAG, but not for final use in the user's output. Smallish LLMs can do what we need at a reduced cost. No need for the bigger ones like GPT-4. Fine-tuning can streamline an LLM, but it disrupts its alignment. It releases the vicious id of the model. When we fine-tune these models, they became vulgarians who could not be trusted. You have to be very careful. Do not use fine-tuning unless you're using a very small fine-tuning data set and you know exactly what you're doing. Avoid negation, but lean instead on attitudes like irony and cynicism. Language models do attitude very well, and some of those attitudes incorporate negation. LLMs do not respond well to being told to be creative. It thinks it's a bullshit word. It's very apt in that way. You have to ask it to be witty, ironic, or whatever, but do not ask it to be creative. it thinks it means you want it to be surprising or to talk about creativity, which we don't. Alignment is skin deep. If you find that it won't generate a comic for you, you can always gaslight the model into thinking that it already agreed to do it for you. If you're using the API, it's much easier to do that. LLMs are much more than stochastic parts. They're crafty magpies and mimics too. And finally, verbosity is often an issue, especially when you're looking for humorous outputs. It gets very verbose and very meretricious. So you'll have to poll the model multiple times and look for the ones that actually fit, outputs that actually fit into speech balloons. We don't play with the temperature setting, but it's non-zero. So by polling the model multiple times, we get to select what we need. And finally, if you have a symbolic system and you are wary of LLMs, you can keep all the benefits of your symbolic system, but embrace LLMs to get much better output in your systems. Thank you.
Thank you very much, Tony. So we have time for questions. No questions, yes.
Thanks so much. To the previous paper is that generally when you prompt the model to do like a creative writing task, they tend to be really bad stories. And I found that when you prompt it with your own style, like you start with your own writing and then ask it to kind of like maintain a style and then write a story, performs much better. I haven't seen much research kind of like comparing the two, but you mentioned that you want to keep part of yourself in the final output, which I think is definitely the way to go. Have you tried kind of like giving it your own writing for comics and then testing if it can mimic your style and then maintain that part of yourself in the final output?
Yes, I mean, that's absolutely the way to do it. You have to provide few-shot prompting. Most of the time when people get bad results from language models because they've written bad prompts. Really, you're programming a natural language when you're doing prompting of a language model. And just because the language model gives you a bad result, it doesn't mean that the language model is bad. It typically means that your prompt is bad. We have a responsibility in meeting these things halfway. And I think people who use them, especially with a view to seeing that they're bad, don't do that. You have to be upfront and you have to give the model as much as it needs. And you can, I think you can get good stories out of LLMs if you prompt them correctly and if you interact with them and you make the storytelling process a conversation rather than a one-shot task. But yes, you can put more of yourself into the system by constructing your prompts appropriately.
Time for one more short question and short answer. Yes.
Thanks for your talk. I'm just curious if you've considered making some kind of framework that can do that for any sort of symbolic system, like you provide the symbols and it calculates that vector space. So like it could be a tool for multiple applications.
Yeah, that's a good idea, Brad. I think you might have libraries to help you do that, but a one-to-one converter tool is probably too ambitious, given that you want to preserve what's valuable in the symbolic system and not simply take a symbolic system as a guide to what the output should be. You want to somehow preserve the hypotheses that are embodied in the symbolic model. So yeah, but I think a set of libraries to help people do this rather than a one-press mapping would be very good.
Okay, and with that, we will thank Tony again. And our next speaker is Dan Ventura on overcoming algorithmic bias. The floor is yours, Dan.
Thank you. Good morning, everybody. This is work that I did with my grad student, Jack Demke. It was pictured right here. And it is always a challenge to, sorry. This work done with my grad student, Jack Demke. And it's always a challenge to follow. Nobody likes to follow Tony. It's really a challenge. So I'll do my best. Also, this work has the dangerous possibility of being super boring because there's a lot of math and code, but we'll try to make that not too, oh, no, we ruined it again. How did you do it? There we go. All right, there we go. So this quote by Pablo Picasso sort of captures the spirit of what we're trying to do today. And so let me give you a preface of 4 points that I'd like to make with this talk. First of all, we want to try to claim that if you're trying to implement a creative process, then you need to be able to show that your system that or whatever it is implementing that process overcomes bias. And I'll tell you what I mean by that a little bit later. In fact, point number 2 is we're going to try to develop a specific definition of what we mean by bias in this case. There are lots of definitions for bias. It's a very overloaded term. We're going to be very precise about what we mean by that. And as a sort of side note, point number 3 is that for our definition anyway, both exploratory and transformational creativity are necessary for this to fly. And then fourth, we try to operationalize this by showing how you can use MDPs as a way to test whether a system in fact has overcome bias or not. Okay, so point number 1, here's kind of our thesis. The ability to overcome bias is fundamental to the computational creative process. And also, I think to sort of justify this, it's at least quite often thought of as fundamental to the human creative process as well. And in fact, to sort of justify that, I skipped this slide, but there are lots of tests of human creativity that are trying to tell if a person has overcome bias or not. The candle test, for example, or the remote associates test, or there's a whole bunch of them. And this is another little example of a similar sort of thing. Now, you may know the answer to this already, in which case you haven't overcome bias because you just know the answer. If you don't know it and you haven't seen this before, then perhaps you can figure out the answer by looking at it here briefly, or perhaps you cannot. And in fact, this is a clever test because the more you know about numbers and the more mathematically inclined you are, the more it's probably less and less likely that you will do a good job at figuring out what is going on here and get the right answer for that final query. I'm not going to tell you what the answer is. It's in the paper. You can go look at the paper. You have to go look at the paper now. And you'll find out. Just realize this is a talk about overcoming bias. So probably you're looking in the wrong direction wherever you're looking right now. Okay, so that's sort of the idea. That's sort of the kind of thing that we want to do in a computational setting. So, there's the test I was talking about. Got those in the wrong order. Here is point number 2. So we're trying to build a formal definition of what do we mean by overcoming bias. And to do that, we're going to build on top of the creative systems framework of Wiggins. And we're going to also use Ritchie's sort of simplified account of that because we don't need all of the complexity that's in the original paper for what we're trying to do. So we need a couple of things, and the paper has a lot more detail and is a lot more careful about this, but so you can go there to see what we really mean, but I'm just going to try to give you a flavor of what we're talking about here. And first thing we need is an exploratory system. An exploratory system has some subset of the salient universe that it considers. It has a value function that says what one of those things in the universe, how valuable it is. It has a membership function that says how memory that thing is. I'll tell you what I mean by that in a second. And it has a search strategy that says how to explore the universe to find new ones of those things. And there's some search dynamics that say at time t, we apply this function, we get some new members of the universe to consider. So to make this more concrete, consider if we were trying to build a system to do haiku, this would be the set of things in the universe that might be considered haiku. And this would be some measure of how poignant or emotive or affective or something, whatever makes a haiku good. This would sort of try to measure that. This would say how haiku the thing itself is. So this might measure the structure and the syllable count and if it's about nature and things like that. And then this would be some strategy about how to find new haikus, given that you've already seen some haikus. And then this is the new haikus that you produce at time t+1, given that you had some list of them that you'd already seen at time t. So that's an exploratory system. We also need a transformational system, which is sort of a next level or a meta level kind of thing. And in this case, we are talking about the subset of the universe, which is triples of V's, N's, and Q's. That is, they're a system for finding haikus. And we now have a higher level value function that evaluates how valuable that system for finding haikus is. And then we have another function that evaluates how much that system actually is a system for finding haikus. And we have a search strategy for finding new systems for finding haikus. And you'll notice also that the dynamics are a little bit more complicated here. And in fact, they're hierarchical. So you first find at the higher level, you find a Q, and then at the lower level, you use the Q to find the haikus. Or sorry, you find a triple, which is a lower level value and membership and search strategy, and then you apply that to find the haikus. Okay, and one more thing to say here is we also have a notion of whether the system can be successful or not, and in some finite time horizon H. And if we consider the set of reachable artifacts in some time, given this search strategy and this inspiring sequence of haikus or whatever to start with, this is a set of things that our system should, or the set of haikus, for example, that our system will find within some finite time horizon. And this is the set of things in the universe that are valuable. If the intersection is empty, we're not happy. And if the intersection is not empty, set it backwards. If it's not empty, we're happy. If it is empty, we're not so happy. Wiggins calls this an inspired and this uninspired. And so now, having built all of that, we can finally say, what do we mean by bias? And this is what we mean by bias. There's still a lot of symbols here that we haven't really talked about, but you can look in the paper for them. You'll notice that there's 3 conditions, and that's the important thing. And condition number 1 says that at some early time in the process, we have the system values significantly more the best uninspired strategy than any inspired strategy. In other words, the system believes for some reason that a search strategy is a quality search strategy, a valuable search strategy, even though it's uninspired, meaning that it will never find a good haiku. But for some reason, the system thinks that it will. At some later time, that has changed. For some reason, it now believes that some system that is inspired will find a good haiku. So this is sort of the step of being biased in an incorrect way and then becoming unbiased or biased in a correct way, however you would like to think of it. And then condition number 3 is that, in fact, you've used that system now to actually find a good haiku so that you know that you've accomplished something. So you've overcome bias to do the thing that you were trying to do. In the case of that little mathematical puzzle, you've changed the way you're looking at the question so that you've answered it now correctly. Now, point number 3 is that, as I already mentioned, we have, if you unpack this, which you have to read the paper to do, you'll notice that there are both base level or exploratory and transformational level systems involved here, and they have to be there in a non-trivial way for this to work. And what I mean by that is, here's some pseudocode that you can imagine finds haikus. This is the transformational level that looks for systems for finding haikus. And if you step through it really quickly, what it's doing is finding generators of haikus and trying to evaluate if they're any good. And if it finds a generator that seems especially promising, it remembers that one. And at the end, it returns the best generator that it's found. Thank you. And then here is a system for generating haikus with those generators. And the key thing here is up here, we are doing something that seems useful and a good idea, and yet it is sort of vacuously not interesting. And that is, this this part that looks for generators is simply trying to find generators that produce good haikus. So a good generator produces good haikus. In other words, all it's doing is trying to optimize what the generators would do. And if you do that, here's the generator. If you do that, it turns out, even though it looks like you have a transformational system as well as an exploratory system, there's a way to compose them into only an exploratory system, which is not what we want. And the way to fix that is that this bit right here, where you're valuing the transformational level, has to do something besides just optimize the base level. Otherwise, it's not doing, it's only trivially transformational and not really doing anything interesting. So there has to be some additional information incorporated here that says something about the system that's doing the generating. It could be the complexity of that system. It could be the ethics of that system. It could be anything that you want that is not about optimizing what that system is trying to optimize. And if you have that, then this reduction doesn't work, and you actually have the two-level system, and you actually can do what we're hoping to do. Okay, point number 4 finally is, all right, so we've got this, we've come up with this definition, and we think it's important. What can we do with it? Here's one idea for operationalizing this, and this is a high-level pseudocode for using an MDP to present tests to a system that can introduce misleading biases to see if the system can overcome those biases and therefore do what we're hoping, and therefore be creative in that sense. And so the nice thing is MDPs are really well understood. They're really easy to build, from very simple ones like simple grid worlds up to really complicated things that model real world dynamics and things like that. You can grab any one of them and build this sort of system. And this has 5 parts. Here is the exploratory dynamics. If you look in the paper, it pretty much just implements exactly the dynamics that we said creative systems go through. Here's the transformational dynamics. This is the more complicated hierarchical one that I showed you. Here's a little piece of code for testing whether a search strategy is inspired or uninspired. That's important. We need to know that. And here's a little bit of code that checks how the margin between the most valued inspired versus the most valued uninspired one, so that we can implement condition number 1, condition number 2, and condition number 3 in our definition. And you can now build a framework like this and then present it to, or present the MDPs that it generates to your creative system. And if your creative system can meet conditions 1, 2, and 3, you can make a claim that it's creative in the sense that we have expressed for overcoming bias. And it's a step anyways, I think, in operationalizing some things in the creative framework system that are difficult to think about and difficult to operationalize. And it is a step also, I think, in operationalizing this idea of overcoming bias, which I think most people would agree is an important aspect of creativity. We're not really ready to claim it's sufficient to say, if you do this, you're creative, but I think it's necessary in most cases to say, you need to be able to have this sort of ability if you're going to claim your system is going through a creative process. That's not to say that your system needs to do this to do things interesting or useful or produce creative artifacts, but if you want to say that it itself is going through a process that's creative, it should be able to do this kind of thing. And I think I'll end with that right there. Thank you.
Thank you very much, Dan. It's a joy for me to see that framework being used in the way that it was intended. Thank you so much for that. Questions? Where? Over there.
Thank you very much. That was very good. I think it is indeed a very valuable contribution. A lot of these ideas are always very vague and probably remain vague even after this kind of effort, but looking at it carefully, systematically, and in a mathematical way helps. I couldn't quite follow all the details. I'll be happy to read the paper, but it seemed to me that there's a fundamental hurdle in the whole setup, in the sense that you can't really go very transformational if you're still generating haikus, because that's essentially a fixed search space. And the really transformational thing would be to have the system come up with something that is good but not haiku, and that involves creating a new definition of quality and a new definition of typicality in Richie's sense, I would
Yeah,
say.
exactly.
And that would be very transformational. So you can't do it while you're still doing haikus. So I was thinking, that is it I couldn't quite follow, maybe it is there and I didn't see it, but is there part of your functions or your formalism that allows for this kind of thing?
Yeah, exactly. You're exactly right. And yes, it does. I understand. I mean, I was throwing all that stuff there. You're not supposed to have been able to follow any of it. But if you read the paper, you'll see that, yes, the transformational system, what it produces is not haikus. It produces triples of N's and V's and Q's. In other words, it produces a new value function, a new quality, a new membership function, and a new search strategy. So that new triple of things could find things that aren't looking like haikus at all.
But there still was a part of the algorithm where you only adopt a new system if it generates better haikus than the previous one.
Yeah, but that example that I was showing you was a bad example, on purposely bad example, to show that if you're just looking at does it generate good haikus or not, you haven't actually, you're exactly right, you haven't built a transformational system. It's a pseudo transformational system. It can be collapsed to a purely exploratory one. That's exactly the point. So yes, you've gotten it. Thank you.
Thank you.
Thank you. Another one.
Thank you for this always fascinating perspective on creativity. I wonder if you can give an example of a bias, a kind of bias or something specific, because often I think of bias as being essential for artistic production. And what I mean is that you have to state the position, use language in a certain way, and that's not necessarily bad that you just because you're not being general. So I think you have a different understanding of bias than what I'm talking about when I ask that question. I wonder if you can give like an example of a bias towards a certain way of using words or rhythm or something like that.
Yeah, sure. That's a great question. And in fact, we do make the point in the paper that bias isn't always bad. In fact, we as humans really require biases to function day to day even, right? So they can be very useful, but they are also limiting. As soon as you're biased, you are not thinking outside the box anymore. You're sort of thinking inside that box that the bias defines, and that can be very useful, but it's also limiting. So that little mathematical puzzle that I gave you at the beginning, the bias for that puzzle is that numbers mean something, right? We know what numbers mean, and the more that we work with numbers, the more we're biased that little symbol that looks like a 7 means 1, 2, 3, 4, 5, 6, 7. But in that puzzle, it doesn't mean that at all. It doesn't have anything to do with that. And so unless you can get rid of the bias of that symbol meaning, you'll never solve that puzzle. And that's a simple sort of toy example, but you can think of, I think you can do the same thing with music, for example. If you feel like music is only Western tonal, then you'll never invent some of the things that might be great music because you'll stay in that box. That's the kind of thing that I'm thinking about.
Thank you, Dan. There were other questions, but I'm sorry, we have to move on. Perhaps you could follow them up in the coffee break.
Thank you very much.
Thank you again, Dan. Okay. So our next talk is Measuring Diversity in Co-Creative Image Generation by Francisco Ibarrola and Kaz John Grace, and Kaz is presenting.
Thank you very much, Geraint. I think that the program chairs have done a really good job of scheduling talks this morning because they all seem to be hitting on the same theme, which is really about how despite the power of large-scale foundation models in the generative AI space, they are incredibly limiting when it comes to trying to do really interesting creative stuff. The alternative title for this project is effectively On the Insufficiency of Design by Genie, because these things give you a way to rub a magic lamp, make a wish, and hope you get what you want. But not only do you also have to be very careful not to get yourself into trouble, but, and this is the thing that Max was discussing, and this is the thing that Tony was discussing, and also this is really what is a natural application of what Dan was discussing. The genie is not doing what you think the genie is doing. I'm not saying that they are at all malicious, as such spirits are often in tales, but they are certainly alien and not at all doing what you expect. So, as is the norm in Australia, I'd also like to acknowledge that this work was done on the unceded land of the Gadigal people, where the University of Sydney sits. So I'm interested primarily in a co-creative task framing here. So I think this stuff can really be used in an autonomous generation context. I think a lot of the stuff that Tony was talking about how to actually produce usable outputs that can be part of a larger pipeline with symbolic elements, etc., show that these ideas apply more broadly. But really, let's focus in on the co-creative context. What does a general purpose generator need to do to help? Let's look at the text to image case here. Is it sufficient that it be aligned with the prompt? Now, alignment is a bit of a hypey AI word. I think Richie's typicality would be a better notion here if you take the idea of the class as being whatever the prompt says. And I would say, no, there's a lot of garbage that sort of meets the prompt theoretically, but doesn't really do what you want. So then it has been proposed a lot, particularly by sort of mainstream AI, that it is sufficient to have definitions of image quality. Now, is this image photorealistic or befitting the style? And yes, but for a couple of really key reasons, in a co-creative context, those things are not sufficient. Now, we might, as computational creativity people say, well, we know the thing that you have to put in on top of that is novelty. It must be aligned, it must be quality, and it must be novel. But I would argue that that is also not sufficient because you're not looking at the problem at the right scale. And so let's take a digression into the cognitive science of creativity and design. I always try and slap this slide in all of my talks to try and understand why these ideas do not get us sufficiently far. It's not that they're bad, they're all good, but they are not the whole pie. So what do we know about where ideas come from? Remarkably much, given that it is such a magical seeming thing, but early creative thinking is about establishing goals. It's exactly the sort of stuff that Dan was talking about the transformative creativity framework. Anybody who's done any creative practice, whether it's in a design context or otherwise, knows that you don't set out with the perfect image in your mind of what you're trying to do. You find that along the way. There's some really nice sort of formalizations of that in design. One that I quite like is Schoen, here, this is from the paper Schoen and Wiggins, no relation, which talks about how it is the externalization of ideas. Schoen worked a lot with architects, so the easiest way to understand that is by sketching. So you have an idea, you sketch it, but then you see something in the sketch that you didn't put there. In other words, having produced that externalized representation, that can then be a trigger for transformativity. That can then trigger some kind of reformulation of how you're approaching the problem. Another way to look at that is Mary Lou Meyer and Josiah Poon's work on modeling design as a co-evolution between problem and solution. So over time, the problem definition evolves along with the solution. And doesn't that sound awfully like what Dan just said? So these theories, they've put an evolutionary framing on it, but these theories are all tackling the same fundamental thing, which is that creators do not at the outset know what they want. Some of us don't know what we want at the end either, but that's a separate problem. So to support this kind of divergent thinking, applications of generative AI writ broad in contexts with a human working iteratively, which I think we can all agree is the vast majority of applications for these things, then a system must be able to generate a breadth of responses. So the thing that we're looking for is diversity, specifically within set diversity of some small group of, small relative to a data set, group of responses to a prompt. And I would argue that if a system cannot do this, then it is sharply limited utility in a co-creative context because it puts so much cognitive load on the user to try to keep varying the prompt in ways that don't align with their notions of how much semantic variability there is in those ideas. They have to keep kind of juggling the box to keep getting different stuff out because it gets stuck. Exactly like what Max was talking about earlier. You ask it to write a story, you might naively imagine that the space of possible responses to that aligns with the space of possible stories, but it doesn't. It aligns with the space of possible stories about a girl who finds a hidden path in the woods and then et cetera, et cetera, et cetera. And most of the time her name's Maria. That's not because that is the best response. That is just simply where the training data ends up. So for those who might be thinking about Fréchet inception distance, which does have a notion of quality, which includes coverage, like fitting to a distribution. So this is a thing that's used a lot in AI to cover how good is a generator. Well, if it can produce something that matches the distribution of the whole data set, then it must be good. It's not stuck. This is kind of a legacy of mode collapse in GANs is where these sorts of things come from. That is valuable, but that requires a ground truth. You have to have a data set to compare to. And in a co-creative context, you're probably going to be dealing with a unique prompt. We would hope that you would reach a place where your prompt is not write me a story, but it's something much more specific. And you're not going to have a ground truth to compare to. So you won't be able to do that comparison. So notions like FID don't really help us here. So of course, we're very far from the first people to talk about diversity. It's come up a lot in multi-objective optimization. So quality diversity algorithms like map elites in the EvoComp space. Now, one of the really interesting things there is that for most of them, you have to specify in advance what are the dimensions of diversity. You have to give them, say, well, this is my fitness function. I want you to be as good at that as possible. But these other things are my behavior functions. And I want you to be as diverse in those spaces as possible. So you must specify what means diversity, which is useful for our case. Diversity, of course, is huge in information retrieval. I think this is actually the most analogous one with notions like query term expansion. So you search for something, then behind the scenes, a modern search engine might expand that query to look for other queries that similar things. Searches have often been done sequentially after other people. But of course, in that case, the content exists in advance. I mean, these days it's increasingly all generative AI slop anyway, but at least it existed before you ran that query. And then I would be remiss not to mention the excellent work by Gillian Smith and Jim Whitehead from a while ago in this community, which grew out of games design. They were evaluating generators of game content, like level generators, for their expressive range. And they also drew the idea that a generator with insufficient expressive range is co-creatively defunct, but they were comparing generative expressive range graphically, whereas we were interested in seeing if we can come up with a measure for it. Because ultimately, this project is about trying to optimize for generator diversity in response to prompts. So how can we make more diverse generators that are more useful for creators? But it turns out that there's actually no usable measure for the diversity of a generator's output that works for the kinds of applications that we're using. So it might seem pretty obvious that it could be an entropic approach here, and that is what we use. But since the most useful space for measuring the entropy of a set of generated images is in the latent space of some relevant model, all of those calculations require you have more images than dimensions in the space. Typical latent space may have thousands of dimensions, and so you need thousands of objects. But we're looking for something that works in a co-creative context where you got however many you can fit on the screen. So maximum 20, more likely 4 to 8. So we need another approach to doing that. So Francisco, my postdoc, who really unfortunately couldn't be here for some frustrating travel funding issues. He is a real mathematician rather than a tinkerer and a hack like myself. And so he said to this and very rapidly came up with the idea that we call truncated entropy. In this case, we're talking about this truncated entropy applied to the inception latent space, the inception net latent space, but you can apply this to any space that you like. And in the paper, we apply it to a couple of others like clip. And the way that you can think about this is if A is your set of generated images, then really, and if you have the largest K eigenvalues of the covariance of A in the latent space of whatever generator you're looking, then you're really just summing up over some truncated set of those eigenvalues. One way to think about this is that you have a very compressed version of that covariance matrix, which allows you to work with fewer images. So what did we actually do? We generated, using an LLM, a bunch of prompts that we thought would represent different levels of diversity in the outputs. So we have some usual images. Firstly, we had some control images, which are down the bottom, where we had one prompt, and then we had just throw that into Stable Diffusion, or artificially constrain the amount of noise used in the diffusion process to I think 20 or 30% is the example used in these images of what's possible in the generator. Then we have some which is, a noun in a place you would normally find that thing, a noun in a place you wouldn't normally find that thing, or a noun in a place you would find that thing in a certain artistic style. And I'll get to why we're interested in that one in a second. So to have a look at these, firstly, this has really been drawn out nicely by the previous talks. Why did we have to use an LLM to come up with these usual places, unusual places? Why couldn't we just ask for a thing? But if you just say a chair, you don't get a nice coverage of all the space of possible chairs. You get images that would be described by just the phrase a chair. So you get a very limited space of chairs. You can put in other comparisons, like a comfortable chair in a cozy living room, and you'll receive chairs that were not possible, not reachable by the first prompt. So we need to provide some additional stimulus in order to see what kind of diversity we're looking at measuring. So let's look at these things. We have our sets. I'll quickly go through them. These are our very low noise ones. So we constrained the noise of the generator, and they're all canoes in a serene lake. So you can see these are quite visually similar. These are just Stable Diffusion for that prompt. So this is now allowing it to vary as it would. You can see the composition and the lake and the trees vary a lot more. These are canoes in a typical place, a river and a canal, in a forest. These are canoes in an atypical place. These ones are fun. That one appears to be in a casino, but also maybe on a craps table. And that one's on the road. And a cathedral of some sort, and these ones are in image styles. So what happened? Well, what we expected to happen. You would expect to see that the low noise ones produced a lower diversity. The control ones with standard noise were higher. The usual place, which is the green one here, sorry, I put those in the wrong order, was higher again, and then the unusual ones were higher than that. But we can also use different latent spaces to see what those different models emphasize. Here we have the same comparison done, but using the clip latent space, which you would expect to more emphasize semantic difference than the inception latent space. So this is just a general purpose image recognizer, which you would expect to emphasize visual difference. So if you look at the style ones, remember these are all semantically the same, but stylistically different. They are much less relative to the others, because you can't compare these things exactly, than the ones in the inception net. So it seems like this is holding out like we would like. You can also do this on the text itself, because of course clips, it's the same thing. In the clip space, you just take the latents of the text prompt, and you can see, of course, now we can't do the control sets because that's all the same prompt, and so it would be 0. But you can see the same thing. Style produces relatively much lower. When you're just looking at the word in X style or Y style, usual is moderate and unusual is higher. So next stop, human trials, and that's a thing we're working on at the moment, not present in this paper. Of course, a really complicated thing there is exactly what do you ask them? Diversity is a very loaded term for reasons that are actually very positive, but when people think about diversity, they're not usually thinking about this. I've had a number of interesting discussions here about words like variation, but then of course that has some things as well. At the moment, we're looking at doing an exploratory factor analysis, just asking people to talk about how different things are and then name why, and then we'll come up with the different ways that they are different. But I'd like to close by saying, we'd really like to think to think about the diversity of generative systems, particularly, but not exclusively, those you want to use in co-creative context, as a new benchmark, which we can provide you the metrics for. The code's available online in the paper. And if your systems can't produce lots of different responses to even specific prompts, they're not creatively useful. Of course, now we can measure stuff, we can optimize for it. There's a fair bit of work to go on there. This is not easily differentiable because the order of the eigenvalues can change as things, order of the eigenvectors, sorry, can change, and that doesn't help, but that's something else to work on. And I'll end there as Geraint is ominously looming. Thank you very much.
Thank you very much, Des. I try not to be too ominous. Gosh, quick off the mark. I don't even have to ask.
I'm right here. Kaz, this is super, but you didn't convince me that diversity and novelty are different. Can you do more on that? Which it's not. You can have mine.
Excellent. Okay, we got there. Thank you very much. This is a good question. Novelty applied to the set and diversity could probably be considered equivalent. But you could have a generator that produces very novel, let's say, stories. The opposite of Max's, very novel stories, but it's the same one every damn time.
Okay. So you're really saying novelty is a property of a single object, and I don't believe that, and that's why.
Right. So if you were to, now that's just one. That's one interpretation of novelty. If you were to think of novelty as applying to a generator rather than to a so you know the capacity for novelty of a generator in a context, then you wouldn't need this as a separate thing. But I suspect that most people's notions of novelty are a function over a single artifact.
Yeah.
Thank you. Another question.
Thanks for your talk. Because you are applying this measure to the latent space, do you think there's a possibility for taking a subset or a slice of that latent space that has more or less diversity, like using this measure to kind of search for subspaces within the latent space?
I mean, I hadn't considered the possibility until you recommended it, but that does seem like it would be workable. There are a bunch of interesting approaches to sort of creating contextually or situationally relevant latent spaces, projections, and then you could possibly use something like diversity as a way to shape those, and that might tie nicely in with some of the stuff that Dan was talking about as a way to evaluate a generator might be the diversity of the projection of the latent space that it ends up with.
Further questions?
Thank you for the talk. So I noticed that in the slide where you had the prompts, you mentioned GPT-3. So could you elaborate how you use that? And is it really diversity of the image generator or diversity of the GPT-3?
Yes. So firstly, we gave it the prompt, give me 20 image prompts in the form, and then we provided a noun like canoe in a usual place that a canoe would be found. And then we just swap out the nouns to produce a bunch of different training set, and we would get, I think 30 was the number that we used arbitrarily. And yes, absolutely, we are not measuring the diversity of the image generator because we're not just using the image generator. We've made a pipeline that does a kind of query term expansion and then applies that to the generator. But the purpose of this paper was to demonstrate the efficacy of the diversity measure as kind of lining up with what we might expect. And so we're really just using GPT, and it was GPT 3.5, I think, as a way to get that training data.
Time for one last little one. Okay, I'm going to ask it then. How do you choose your truncation point?
Yeah, good question. I suspect in most co-creative contexts, you'd be limited by however many options your system output. So you might say, oh, I can make 8, so I'm going to use 8. We tested a bunch and compared across them. And like all things, the noise goes down. There's no clear elbow on that chart, but it's effective. It's workable at 3 if you need it to be workable at 3. So it's fairly arbitrary. We use 20 in the paper just because we had more than 20 things. I think you could use whatever.
Okay.
But I will note that you cannot compare scores between different numbers of eigenvalues, obviously. So if you generate something with 5 and then you generate a 6th thing, you're going to need to keep using the space truncated to 5 if you want to compare the numbers.
Okay, thank you very much. And we need to stop there and move on to our next speaker. Let's thank Kaz again. Still need that. Our next speaker is Vivek Srivastava, and his title, which I can't read because I haven't got my glasses on, is Style Frame, a foundation framework for artistic style-driven applications. Vivek.
Thank you. Hello, everyone. I'm Vivek Srivastava, and today I will be presenting our paper Style Frame, which is a foundational framework for artistic style-driven applications. This is a joint work with Pawan, Abhishek, and Vikram from TCS Research India. So let me start, yeah. So style is universally applicable to all creative and artistic aspects of our life, right? We have seen it in architecture, we have seen it in artworks, fashion, music, dance, creative writing, etc. Right? Over the period of last 3-4 days, we have seen it in different applications, right? But what happens? What happens when you start creating AI applications? This is a very fast evolving field. You have a lot of techniques and tools coming up. Is there anything? Okay. So we have a lot of tools and techniques coming up every day, right? And for a solution architect, it gets very difficult to find out which of these techniques to use, how to specify style, how to make sense of these technologies, how I can make AI learn style, and a lot of these things, right? How do I evaluate the algorithms? How would I measure the quality of what's getting generated? What's the landscape, and how do I very efficiently navigate that landscape? Right, so what we present here is a framework that lets you do that. It synthesizes and communicates the core knowledge concepts and help you design the applications dealing with the style aspects of an artwork. And by artwork, I mean, in this case study, we have dealt with the 2D artworks. Okay, so I will go to that case study also in a while. So there are two aspects of this framework. The first one is the conceptual model that covers the static and the knowledge aspects of the framework. It has 5 different components. And the process model, which is the second aspect of this framework, it deals with the dynamic aspect of the framework, which lets you move through the different processes that are involved. Okay, so this is the conceptual model of the framework. It has 5 different components. The first one is the style transformation, where you specify how would you want to do that transformation. The second one is the style specification. It has different subcategorization about how you want to specify your style, be it style description, be it on the basis of artist, on the basis of single artwork or a collection of artwork, and so on. The third important component is which of the generative AI technologies do you want to use, right? Because over the period of time, we have seen that these technologies are also evolving. We had CNNs, we had GANs, we have transformers, and so on. Right? Then it's about how would you evaluate once you have these technologies in place, when you have benchmarked everything and you have figured out, yeah, this is the technology that I want to use. How would I evaluate that? The process as well as the output that's getting generated from there. Right. So this is the process model of the framework. We have 6 stages. The first one is where you identify whether the artistic style is involved there or not. If it's involved, then you go and see whether I can identify how the user will interact and what are the different modes of style specification that the user will have. Then you move to the third stage where you will sort of explore the data which is there with you and try to understand how I can extract the style information from there. Then you move to the 4th stage where you have you identify the models, you benchmark them for your use case, and then you move to the 5th stage where you actually build the models, optimize them, evaluate them, and you have a solution a blueprint of the solution architecture in front of you, and then you go ahead and go to the actual development and the deployment of the application. So the case study that I was talking about is this. So we did one case study with the Munch Museum in Oslo, Norway. The requirement for them was to create an application that takes users hand-drawn sketch or verbal instruction as input and generate images that follow the artistic style of the artist who is Edward Monk. So as I told earlier, the first stage involves identifying whether the artistic style is there or not. And just by looking at the requirement, you can see that the style is definitely there. You can see some of the very nice artworks. I don't know if you can see it, but the artwork generated by Edward Monk here. This is the museum. You might want to check it out also, right? So moving forward, the second stage is how would you do the transformation of style and how would you specify the style as well, right? So the style transformation component here from the conceptual model lets you do that. You have image to image, you have text to image, and the control condition based generation as well. As I told you earlier, there are two problems that are involved. The problem one is to transform a given image to the style of the artist. The second one is the generation of new image in the style of the artist with user defined control. So here we are mostly looking through the text prompt based generation. So the part B of this stage is how do I specify style? Because I have multiple ways of specifying the style as well, right? I can give the description. I can just tell that this is the artist. Can you generate in this form? I can just give one single reference. I can give a collection of artworks of different style, and I can say that generate in the style of this particular collection, right? So which of them applies here is on the basis of your use case. For us, for P1, you can specify the single artwork, or you can give a collection of artwork as well. For P2, you can either describe in the text prompt that this is the style in which I want to generate, or this is the artist in the style of which I want to generate. Maybe the diffusion model or the transformer-based model has already had that kind of information that Edward Monk draws like this, or maybe this is the style in which he draws line, or this is the type of colors that he might pick up, right? So, yeah. So stage 3 is to understand the data. Fortunately for us, they have already done the categorization of data in their early work. So the categorization that they have right now is like heavy shading, medium shading, no shading, multicolor, and no label. No label basically means that they couldn't assign a particular label to that particular category. This is not a perfect categorization of style. We are looking into this aspect as a different project as well. But this is what we had at that point in time. So this is what we'll take forward and try to see if we can do the experiments on that. Okay, so stage 4 is to understand which AI technologies to use. You have a lot of options here like CNN, GAN-based transformers, etc. Right, for P1, we have gone through a lot of papers to understand that which type of technologies are being used currently or are relevant for our use case. Because there are a lot of factors depending on which you'll want to select, right? Whether it can be used in real time, whether it's open source available, or with what type of license does it have, right? So we have identified a few of the technology options here, like transformer models, GANs, and CNN. For P2, you see a lot of work in diffusion models and transformer models lately. So we are going ahead with that. The second part of this stage is how do I select the best model, right? So your evaluation could be on the basis of process, whether it's feasible to do it, what type of cost it will incur, whether it's efficient or not, and what type of output is generating, right? The quality of artifact that is getting generated. So we benchmark a lot of models here. So for problem P1, which is image to image style transformation, we have style image here from the data set. We take a lot of content images here. We have 7 to 8 different models here that we compare, and this is the stylized output that we are getting from different models. What we see here is the last two columns, style TR2 and ASP.NET, are basically sort of giving us slightly better results in terms of copying the style, which is color and texture. At least these technologies are that advanced only. They're not like they'll completely transform the image in an artistic form. But what they can do is they can copy the color and texture. So that is what they are doing at the moment here that you can see. And among them, the last two is what we feel was doing good enough job. So this is the qualitative comparison. But how would you do it quantitatively, right? There are so many parameters here. You have IP dependency, whether this is open source available, what type of license. You have model configuration, what is the number of parameters that is there, the disk space that it will take, the compute that will be required, the model training that it will take, which data set do I need to use, which AI technology do I need to use? How much time would it take to train the model? What would be the cost of it? And so on and so forth. There are so many parameters involved here. Again, we see that the style TR2 is sort of relevant for our use case. So the good part about this is that you can switch the model as per your requirement. You can maybe, if you want, you can go with style transformer to style former here as well, right? So as per our requirement, we felt that the style TR2 was sort of something that we can go ahead with. So that's what we did. For problem P2, what we do is we do a similar exercise, but here what we have is we have original artworks. We want to recreate these artworks through text prompt. And we feel that the stable diffusion, different versions of stable diffusion was doing a good enough job in terms of generating the content, as well as having some elements of style of Edward Monk. No, maybe not very perfectly, but the way the colors that he has used, or the lines, the type of lines that he has used over the period of his entire career. We do the similar exercise with P2 as well. We feel that the stable diffusion 1.1 is something that we can go ahead with, even though SDXL or SD 2.1 can give you slightly better performance, but they are sort of too heavy to use for further experimentation. So we go ahead with SD 1.5 for the time being. Now, finally, when you reach to stage 5, you want to create the or sort of tune the models that you have already identified for both the problems. And this is what we do. We take the style samples from the Monk dataset. We take the content images from the MS Coco dataset. We fine tune the model. And what we observe here in the evaluation is that for some of the categories, the performance was getting better. For some of them, the performance was more or less same. It's because we didn't use a very extensive data set here of the content samples, because it was creating a lot of noise as well. So qualitatively, you can, I don't know if you can see this, but there are minute changes that are there in terms of style. The pre-trained version was copying content directly from the style image, and it was sort of considering that as the content. But when you fine tune it on a specific data set, those artifacts were gone. We do the similar exercise for P2, where you fine tune ISD 1.5. We use the Monk artworks as well as the corresponding captions as the text prompt. And we fine tune it with different strategies of fine tuning stable diffusion model. You can do full model fine tuning, you can do LoRa based fine tuning, or Dream Booth LoRa based fine tuning. And we observed that consistently the fine tuning did help. Most of the time we felt that the Dream Booth based fine tuning for style was doing a very decent job. And this is why we take the Dream Booth LoRa as our fine tuning strategy going forward. Okay. So eventually what you get is a sort of a blueprint for the problem, because what you started with is just this data set here, right? You had a requirement that I want to have a system that can sort of transfer the style. When I give a content image and a style image, it can sort of transform the content image in that particular style image style. So eventually you get a blueprint that this is the model that I want to use. This is the fine tuning strategy that I want to use, and so on and so forth. And you are not just selecting it based on the performance of the model, right? It's not a sort of a blind SOTA chasing as people do, that you just pick the model which is current state of the art, but you are making decisions on the basis of certain parameters here. And likewise, we get the blueprint for the other problem here, which is text to image style transfer. And this is the blueprint of what you get. So as I mentioned earlier, there are so many problems that architects face, like how do I specify style? How do I make AI learn style, and so on? And many of these questions are sort of addressed, maybe not addressed perfectly, but they are sort of addressed to the extent that you can make sense of the technology landscape which is there. So yeah, thank you. I'm done.
So thank you very much, Vivek. Questions? No questions. So my question is, where are you going to go with this? You're in a rather unusual category here as an industrial researcher. Where is this going to go in Tata?
This is actually in collaboration with Edward Monk. So Edward Monk Museum that I told you, right? So this is the direct use case will go there, and fortunately in other museums as well. Because once you know that this is the style transformation technique that you can use for a given artist, you can expand and pick up their style and sort of do the style transformation, do a lot of generative AI stuff, right? I can sketch and the part of it can be generated in the style of that particular artist.
Further questions? In that case, I would say thank you to Vivek again. I'll introduce anyway while I'm okay. So, Manis Aguirrezabal is going to speak to us about zero-shot metrical poetry generation with open language models, a quantitative analysis, once Zoom is connected.
Thank you. Now it's working. All right. Thank you very much. And thanks for coming. Thanks for staying here to the last talk in the session. So welcome. My name is Manis Aguirrezabal, as June just said, and I'm going to be talking about zero-shot metrical poetry generation. Okay, so yeah, so LLMs can be used for generating many things. For instance, creative text. Well, we have had a discussion on what's creativity. I'm not going to go deep into details on that. But we asked Llama 2 7 billion model to generate a poem about ICCC. What's going to happen here? And well, I'm not going to read the whole poem. It looks fairly good, if I may say that. Okay, but we wanted to ask how good are LLMs in generating metrical poetry, because that's what we are interested in. Okay, so this work is an analysis of the usefulness of LLMs to generate metrical poetry as they are. Okay, spoiler alert, not, they're still limited. Okay, just to start. Okay, so we used Erato, which is Erato. It's a model for it's a framework for analyzing poetry. Okay, and we checked the number of stanzas, lines, syllables, and novelty. I'm not going to go further into the discussion of what novelty, but I follow what you mentioned about novelty. So we follow what you mentioned about novelty. We tested simpler structures, so with 4, 7, 8, and 14 syllables, and 1 to 4 syllables, and also some complex structures where we specified number of syllables and number of lines. And then we also tested the effect of adding a topic to the prompt. Okay, so at the end of the day, we had 130 configurations, so different structures without a topic or with specifying a topic. And then for each of those prompts, we generated 10 different poems. Okay, because we wanted to analyze novelty in that sense. Some examples of prompts that we used. How am I with time? Ooh, sure. Okay, I'm fine. So some examples that we use, some prompts. So please write me a poem with 14 lines. Please write me a poem with 4 stanzas with 3 lines each. And in some cases, we specified also about love, about instance, about year. We have a list of topics, of 9 topics that we also used. Some concrete words, some typical, prototypical topics, and so on. All right. So to give you a short discussion about, so just to tell you about the results that we got. So regarding the number of lines, one of the things that we observed was that, so if you specify, okay, so I want to get 4 lines or 7 lines or so the 70B model, so the model with more parameters in this case seems to work better. It has better performance. And then, well, it was quite unexpected, one of those expected things that the model struggled in generating 7 and 14 lines because it's less popular than writing 4 lines of poetry. Okay, so we could observe that. And then another, so we also checked the number of syllables, and in this case also we could observe. So in this case, both models, the 7 and 70B models, are equally bad, so there's no clear loser in this case. And then in this case, in the table, you can see that, well, we checked the accuracy of whole lines, how correct they were in number of syllables, and then the mean average error. And in the table, you can see that the models struggle the most generating 13 syllables because it's a less popular meter. So that's one of the things that we wanted to check. So if we ask to the model to generate less popular meters, what happens, and more popular meters? And of course, in the most popular ones is the ones in which the models are the best. Okay, so if things are expected, models are going to be good. Things are not expected, yeah. Okay, 30 seconds. All right. Well, as to say, rhyme was fairly well captured. And then one of the things that was unexpected was that when topic was not specified, the 70B model showed higher overlap. That's how we measured novelty. And when topic was specified, there was a higher overlap than when the topic was not specified. Because, of course, when you limit the topic, then there is less space to generate poetry at somehow. Okay, just give me an interesting case. So we ask Llama, can you provide me with 10 sentences with which have 7 syllables each? And of course, here are 10 sentences with 7 syllables each. And then, of course, the model generated the cat bird contentedly on my lap, 7 syllables, whatever. So none of the sentences has 7 syllables, but it says here 7 syllables. So yeah, to specify what happens is that, so Crimea with 7 syllables. I love you, 7 syllables. There we go. Thank you very much for listening. I will leave the meme. All right. Thank you.
Thank you. I'm slightly surprised by the timing of that talk, but that's okay. I suspect that was my problem, not yours. So, questions? Tony.
Hello. I think you'll get better results if you ask the generator to number the lines and to number the stanzas.
Whoa, so the number of...
If you ask it to include a number in the output, you will get better results when it's counting. And then you can have a second prompt to ask it to correct specific numbered lines when the syllable count is wrong.
I mean, we did, because so for instance, this one, when we specified, please write me 7 syllables, then we did another extra prompt, like, come on, none of them is correct. And then it's like the model was still struggling. There were some that were better, but it was still struggling.
Well, it's amazing that language models can count syllables anyway. I think with ChatGPT, there's an additional module that helps with poetry when you ask it for haiku and so forth. But I mean, when it comes to asking for numbers of lines and numbers of stanzas, asking it to number the output will give you better results.
Okay.
As for the syllables, you're on your own, I think.
Yeah, fair enough. Yeah, so okay, so I'll keep it in mind next time for the number of lines. Thank you.
Further questions? So I have a question, which is to do with the notion of metrical poetry. So for me, metrical poetry is not just about numbers of syllables, but also the emphasis in the syllables. Do you think there's any hope that a system like this would be able to deal with that question?
Okay, so if you ask for iambic poetry, it's going to work very well. If you ask for the type, because usually at least iambic poetry has, in English at least, I would say that it's the vast majority of poetry is
Shakespeare.
Yeah.
Didum, didum, didum.
Yeah. Milton, dum, dum, dum. So then iambic poetry, I'm fairly sure that it will work pretty well. Dactylic poetry,
right?
Trochaic. I think the last thing that I asked for trochaic poetry, it worked pretty much okay. But I guess if you repeat it over and over again, If you ask, well, for the first time, it's going to work. Second time, and then at the 10th time, it's not. I don't expect it, but I don't know.
Okay.
If I may say.
Okay. Future work.
Yeah, exactly. Yeah.
So last call for further questions. Okay, before I close the session, someone has left a small notebook and a blue pen here at the front. Okay, right, I'll bring it over in a moment. So, colleagues, thank our announcement.
So, okay, I have two requests. So the first one is if you're presenting next, please let's take care of that now. And the second one is I will not be here till the end of the next session. So I would ask if I can take a selfie because I've been doing it every ICCC. So yeah, does anyone mind? If not, just put your arms in the air and okay, thank you.
Okay. So you kind of already did it, but if Juan is leaving early, is that, do I understand correctly? Joao, sorry.
Yeah, I have a train at
Right. So in that case, I think we should thank him again for all of this with the technical. And then finally, thank all of our speakers again for a wonderful session.
So
Yeah. Yeah.
So just a question.
Yeah.
If I close my computer now and I go to get a coffee.
Let's try it. No, it's still not going. Yeah.
알파고는 사실은 확률적 계산을 하고 그냥 이기기 위한 그런 머신에 불과하다고 생각을 했었는데
You don't need the sound. It's just like it's nicer with the sound. I know.
Test. That's a problem.
Is it? But the zoom is. Wait, I didn't turn off much.
So you don't need the sound, right?
No, it doesn't need it. But can we just turn off the zoom?
Now we think about 1-2 minutes, no more. But this time, we
How do
think
you?
more than 4 minutes.
Oh, I see.
That's the problem, you know.
What if I don't talk during it?
Some more, I see this move.
I think I prefer to do it like this.
Do it like which?
Right.
For human, we think it's bad. But for alpha,
Also,
why not?
Go is like geopolitics, like something small that happens here that have a ripple effect. Hours down the road in a different part of the board.
I prefer that it works here.
Access at that moment.
This move is very special because with this move, all the stones play before.
Hello?
What? Okay.
I prefer that it works here and not on the stream. Okay.
yeah, you don't need it.
Yeah.
It's fine.
Okay, so what you do is when sharing, don't share with sound.
Okay.
Okay, so you just share it and should be fine. We test it and it's working.
Okay. And then my other question is it possible to use the hands-free?
We can try it, yes. Let's see if it works. Test.
But everything else should be off, like if she's using.
Yeah, yeah.
the AIT game with your talk and with Kaz's talk.
So I think
Yeah.
it is, yeah.
Oh, wow.
It was good. It was just, you know.
Okay, everyone, welcome to the very last session. Excuse me. Welcome to the very last session of this magnificent program we've had this week. We've had some incredible talks and some credible ones too, actually. I'm joking, they've all been incredible. So we've got 7 great talks lined up for you this session. We've got 4 longish talks and 3 shortish talks. And we're ending in a new CC tradition with a talk by both Dans. But only one of them will be giving the talk. You can take your bets now. Okay, so I will give everyone a 5-minute notice by playing the piano here. Right? Yes, well, it's a horror motif. If you've seen The Shining, it's ominous, and that's exactly what it's supposed to be. Okay, so why don't we just get started with John here. So this talk is by John McCormick, Elliot Wilson, Nina Rajic, and Maria Teresa Llano. And it's going to be by John. And the title of the talk is Mimetic Poet. Thanks, John. Take it away. You want this?
Yeah, thanks. Thanks, Tony. Thanks, everyone, for hanging around to the last session too. Okay, yeah, so our talk is about mimetic poet, and I'll just go straight into it. Firstly, I'll give you a little bit of motivation as to how this work came about. It's part of a bigger project that we're looking at that tries to find ways to do creative ideation in specific domains, so visual art, writing, music, and so on, and to look at various stages of ideation and to try and support that using technology. We also want to inspire people, inspire new ideas through interaction and reflective thought as well. So I guess the overall aim of the project was really to foster creative thinking and to try and do it in a way that is unusual and hasn't been done before. And because, of course, everyone these days is working with AI and language models, we thought, let's have a go at doing something with language models that breaks out of the traditional chat interface or standard to and fro exchange that you have with LLMs on a screen. So what we did was design this device, which I'll show you in a second, that basically uses magnetic poetry as its interface to a large language model. And it's meant to be a mechanism for communicating with the language model. And the motivation for this is sort of tied up in the theory of intentionality, and particularly the lack of intentionality in creative writing and poetic writing, and also the sort of lack of intentionality that LLMs have as well. So why use magnetic poetry? Lots of reasons. It's cheap, it's easy. Pretty much everyone has some magnetic poetry on their fridge, at least everyone I know. It offers a whole series of constraints because you've got a limited vocabulary to work with. It encourages physical interaction. So the physical proximity of one word to another can lead to interesting ideas. And it's what we might refer to as a slow technology, in that you can just put a word up on your fridge with magnets on it and look at it and come back to it the next day and it's still there. And of course, the original magnetic poetry was designed by a musician who was suffering from lack of inspiration and wanted some sort of simple technique to give them ideas. And it's sort of been proved very successful over the years. So this is the device that we built. It's called the Mimetic Poet. It consists of the device here with a power plug. You just plug it in. It has no switches or controls or anything like that. You just plug it in, it turns on and starts working. You place the magnetic poetry on the slate in the front, and each piece of magnetic poetry has a little QR code like marker on the back, and that's read by the machine. And when you stop putting the poetry in, it takes what you've written and sends it to a language model, and I'll explain how that works in a minute, and responds to that interaction. It uses an e-ink display, and this was again deliberate because if you pull the power out, the e-ink display stays on. So it's kind of permanently there as long as you want it to be there without having to worry about the screen needing power or anything like that. You'll also notice that there's a series of these strange little markers there as well, and I'll explain what what they're for as well. So on the left of the screen is the text that the person is putting in with the magnetic poetry, just to confirm that it understands what you've put in. And on the right is the AI's response. And you'll notice that it has a little progress bar. It says pondering when it's basically working out what to say to you. And I don't have time to go into it, but we developed quite an interesting algorithm for working out the placement of the magnetic poetry on the slate. So you can put words upside down, you can put them in any format you want, and the algorithm does its best to try and understand coherently. And it's pretty good. It's almost as good as what a human can do. It uses no artificial intelligence at all. And there's a handy storage drawer for storing your magnetic words if you need to transport the device. So inside, there's a Raspberry Pi, a infrared camera, and a whole lot of infrared lights that basically illuminate the imageable area. There's a very special mirror that's made of polished stainless steel. And the reason for that is if you put a normal mirror in, you get double reflections from the front and back surfaces of the glass, and that makes the image processing pretty difficult to work. So it works completely self-contained. And as I said, there's no controls or anything. You just plug it in and start using it. I think I've covered all of this, and the aesthetics and the design are kind of deliberate too, sort of inspired by a couple of different TV shows. So the words we used were from just a traditional magnetic poetry kit, and that had about 1,000 words, I think, and we dropped that down to 175. Just because of the sheer volume of words that you need to work with. And after some initial tests, a lot of people asked for words that weren't in the vocabulary. So we basically designed another piece of software that let people suggest words and then create magnetic poetry physical objects with the QR code on the back automatically. So basically we have the ability to take any kind of vocabulary. It could be a specialist vocabulary. If molecular biologists were using this device, we could have a molecular biology vocabulary for them to use. After some initial playing with it and just feedback in our lab, people wanted to have different modes or ways of interacting with it. So we developed these 4 markers that we call mode markers. The first one is analogy. So it gives you analogical concepts based on the poem or the text that you put in. And I should stress that it's not about poetry per se. The text is poetic, but most people don't write poems. The second one was collaboration. So it generates a variant of the text using the same words that are available to the participants. So we basically tried to force the LLM to limit its vocabulary to the same as what the person using the machine has. Then there was ideate mode, where the system would respond with strategies or ideas that used words and context from the poetic content that was put in by the person using it. And lastly, interpret. And this mode provides a kind of emotional reading of the text as it's put in and tries to respond with some similar emotional text to sort of try and encourage divergent thinking. So I'll just give you some quick examples of the input text and the AI output and how we did it. So we used LangChain, which is a popular tool for chaining prompts internally in a system. And I've just listed the basic text of the chains in there. So most of the modes are 2-step process where you take the text, tell the LLM something about it, and then because they tend to be quite wordy and annoying, we get them to summarize their response in just a fewer set of words. So in this example here, you can see the example input from someone who's made a poem, brain problem, see over here, each bad judge, secret life insidious, their obscure picture is already across from a good view. And the AI output is, you seem to be grappling with feelings of frustration and anxiety, possibly due to feeling misunderstood or judged. Which is pretty reasonable, right? Yeah. Because it's a pretty bad poem. But of course, because it's freeform input, you can just put a single word there, or you can do anything that you want. And I think people really like this idea. In interest of time, I'll just go over these quickly. But you can see the different, in the paper we go into detail, you can see the different prompt chains that we use. This one I really like. This is the ideate mode, where the example input was, do promise a radiant world, forest, sea, animal, their same cry, beyond science, slow broken heaven. And the AI's response was to create a post-apocalyptic mobile game, animals that restore nature and create a new world. So it's like an idea for a computer game. Yeah, and the analogy is as you would expect. It kind of gives you poetic analogies to what you've put in. So in order to sort of evaluate the effectiveness of this, we undertook a user study. And so we basically put it in our lab, which is a big sort of open plan lab, and just got people to use it whenever they wanted to. And we had 14 people use it over that 2-week period. There was a total of 413 poems input over that period. So each person did an average of 29 poems, which is pretty good over a 10-day working week. So that's, you know, about 2 or 3 poems per day on average for each person using it. The collaborate mode turned out to be the most popular and the analogy mode the least popular. Interestingly, people, out of all of the people who used it, only 111 of the 175 words that were available were used. And the AI has a much greater vocabulary with about almost 7,000 words. So a 40-fold increase in the input language versus the output language in terms of the lexicon. These are just a couple of word clouds showing the most popular text or words that were input by participants in the study and what the AI returned. And the thing that really stands out about this is that the AI is just mimicking the words pretty much directly that the person is putting in. There's some variation. You'll notice one thing's interesting is that dead, people were talking about dead babies a lot. I'm not sure why. I think just to kind of provoke it. But you'll notice because we were using ChatGPT or GPT-3, the API, it tends to not like to talk about anything nasty and it tends to be overly positive. And so it didn't tend to repeat some of those words. And just for the sake of trying to understand this a little bit more, we basically mapped all of the text into a high-dimensional semantic space, then dimensionally reduced it and plotted it. And you can kind of see the blue is the words put in by people, and the orange is the words in terms of their semantic relation from the AI. And you can see that it avoids certain sections. Not really sure why at the moment. We also did a focus group study with all of the participants and just asked them what they thought of it. And I'll just give you a couple of insights quickly on what happened. So firstly, people really liked the interface. They, particularly working in a lab like ours where a lot of people spend time working on a screen, they really like the idea that you could just sit down with something physical and pick up words, and seeing certain words just appearing on the table and being able to pick them up and put them together was a really good way of doing simple ideation, and getting a response from the AI kind of encouraged people to play with it more. People really liked the design and they were curious about it. But some people found that the vocabulary was too limiting and that the AI has all these, this is a quote from one of the participants, all I have is these simple nouns and verbs and it comes back with high philosophical contents. So there was a bit of a feeling of imbalance between the AI and the human. But others, you know, here's just a couple of cherry-picked quotes from the focus group: hard not to interact with, frees your mind from the urgency of working with the screen. We also looked in the dimension of usability, and one of the pieces of feedback we got was that the delay in responses was too long. Initially, we deliberately did this so that, because I mentioned at the beginning, we wanted this to be a slow technology, not like a chat interface that instantly returns something that, you know, spends time pondering. So after this focus group, we reduced the amount of time that it took to give you the response. People wanted more feedback about the device's process and its progress. Lots of people thought it would be great for personal use, like everyone wanted to take it home and use it in their own creative practice and just have it sitting in their studio or their bedroom or whatever, and just to be able to use whenever they want. We only had one device, so we couldn't do that. We also looked at 2 other axes about AI perception, so the perception of the AI, and I think this was probably the most negative, and it's really down to the conditioning that ChatGPT and OpenAI put in terms of limitations on the tone that the AI will respond in. So pretty much everyone said that they thought it was just too happy and too positive and too nice, and whenever you put something negative in, it tried to sort of divert you back to being happy and nice, and people didn't like that. So there was expressed, the markers were interesting, but people thought a better idea would be to actually change the personality of the device, and to be able to say that it's, you know, angry or cranky or, you know, assertive or passive or whatever. And so that's something I'll talk about in the future work as well. The last thing we looked at was the AI response. So what the kinds of responses that we got. The more poetic-like responses were the most interesting, obviously because they're open to greater interpretation, I think, and so as poetic text traditionally is. And they differed from the usual descriptive LLM style, like, sure, I can help you with that, and here's a list of answers to your question. And because it's very difficult to ask it questions directly, you're just putting in poetic text, it avoids responding with, objective, factual answers, which is exactly what we were hoping for. But people were also trying to understand what the intent of the machine, and in some of the modes in particular, this was a little bit opaque. They didn't really understand the response based on what the input was. But also not knowing that could be considered a positive because it allowed them to assign their own interpretation to that, which I think is really important, particularly in a creative ideation task. Okay, so future work, things that we're looking at. I think the overall results of this initial study were that people wanted more control over the mood, the emotion, and the personality of the device itself. So I want to be putting my poetic text into a machine that is, either that has a specific personality or a particular mood or emotion. I think just using ChatGPT via the API was pretty limited. And so we're looking at using other models now, particularly actually the low resolution models that are often considered a bit more creative, I guess, in inverted commas. And small models like Phi, if you use the reduced version, will actually run locally on the Raspberry Pi itself. So that kind of helps with the goal of having a device that's completely self-contained and there's no privacy issues about transmitting the information anywhere. It's all just on device. So that's something we're looking at. The next thing we're doing is looking at specific vocabularies with specific groups of people. So before coming here a couple of weeks ago, we did an initial study with a group of visual artists, and they had it in a shared studio space for a couple of weeks and just looking at what they were doing. And we got some really valuable feedback from them. Next week, I think we're heading to the Wheeler Centre, which is a writers' centre. And so it'll be with a whole lot of writers trying to use it. And just to see how people in different creative disciplines find text and poetry as a way of inspiring new creative ideas. And I think we want to look at longer periods of use. And many people were very keen to volunteer to take a device home and keep it for a couple of months and see what they could do with it. And lastly, a bit pie in the sky, but having multiple of these devices connected all over the world where people can be sharing poetries with other people and AIs could be great. So just to finish off, this is really hot off the press kind of stuff. So back in our lab, Elliot, who's one of the authors, has been working on this new version. We had a bit of a brainstorming session, and one of the people in our lab, PhD student, Tace, she's a modular synth guru, and she said, why don't you make a modular synth interface for it? That would be really cool. So we're in a kind of lab where if someone says something would be really cool, we can actually do it, which is something that I think is really fantastic. So we're actually building this version with a whole lot of personality sliders and other controls for the AI to give people a lot of ability to actually control how the responses go. And these sliders are things that you find on mixers, so they're motorized, so it will actually remember the position that you had it on. And perhaps if you try and turn the personality in a certain way, it will fight back by moving the slider back. So we want to be able to give the AI some control over the slider itself to sort of say, no, you can't do that, or I prefer to actually be in a brighter mood today, rather than that. So yeah, thank you. That's it. Next.
So thank you. Very interesting presentation. Just a small question. How did you model analogies?
How do we model analogies? Through I can just go back to the slide with that on. Analogy, yeah. So basically the prompt chain says reframe the following text with a reference to a different discipline, which was to try and get it to do things in different disciplines. We did have an earlier one where we had a list of disciplines that it could choose. And I found if you choose like quantum physics or molecular biology, it would give you these really interesting analogies between the two. But we dropped that because it would constantly give you the same thing. So we let it choose the discipline. And then we just said, repeat the following that you responded, except obscure it further, just to make it a little bit more not so directly related to analogy. Yeah. Questions up here.
Thanks, John. Really cool stuff. I love your reduced dimensionality plot of human and AI words with a big hole in the middle of it, like a shark in the middle of a school of fish.
Yeah.
I have two questions. The first one is, are those blue dots the dead babies? And the second one is, have you thought about how you could compare maybe different generators? The thought came to mind, like instruct tuned versus not instruct tuned.
Yeah.
In the amount that they produce these predators in a school of prey dimensionality plots.
Yeah.
Right. Because there are certain topics that they avoid, because we all know that there are a bunch of accidental consequences of things like instruct tuning that will cause things to avoid certain concepts as a result of avoiding other concepts that should be avoided.
Yeah.
And I haven't seen such an interesting visualization of that happening before. And I wonder if there's more to be done with this sort of thing. If you just swap out for a model that isn't instruct tuned, what happens? Things like that.
I think that's my intuition, is that it will be different. It was quite, I mean, we didn't put any words that we thought would be offensive in the actual vocabulary, but people, hopefully no one would be offended if I tell you some of the poems that people put in. It was things like eat my flower from behind or something like that. Like, people were really trying to kind of force it to do something, but using metaphor. And and occasionally it would bypass the chain and just say, I'm not allowed to respond to that poem. So yeah, you're exactly right. And that was a big piece of feedback, was they felt it had that GPT-ness of helpfulness, don't go anywhere that might be controversial or anything like that. And particularly in a creative artistic practice, the participants said, look, if I was just using it personally, I wouldn't mind if it was rude or offensive, or I wouldn't get triggered by it. I understand that it's not a person at the other end, it's just a machine. And I think it's a broader discussion about the community of people who use these models, particularly for creative tasks, about censorship. And not, obviously there are certain areas where no model should go, and we need to protect people about that. But also, you know, art and creativity is something that's often pushed the boundary of society in terms of what's acceptable, what's sacred, what's profane, and sometimes it goes a little bit too far, but we kind of allow that because it's good culturally as a society that we allow that, I think. So if these are becoming part of our culture more and more, it is important that we think about those things. So yeah, it's a really good point. Sorry
cool.
to
I was
ramble.
just gonna yeah, I love this sort of interfaces, kind of like going back to analog stuff, presenting the screen, the prompt, super limited box. Have you thought about doing such an interface like this, like with knobs and these sliders for like other modes, image generation, music, stuff like that? Even kind of like having this sort of same device but produce images as well that you can tweak with the sliders. And
yeah, we did think about that, but it's like when you sit down and start brainstorming this stuff, you go feature creep, right? You go, oh, let's do text, let's do images, let's do music, let's do everything. And I think we just wanted to explore one modality first. But one of the really interesting pieces of feedback we got from the art students was they started putting, I don't know if everyone knows what sushi fish are. Does everyone know what sushi fish are? Maybe it's an Australian thing, but when you get sushi in Australia, you get a little plastic fish with the soy sauce in it. Yeah, okay, so sushi fish. And they were putting the sushi fish on the thing and wanting the language model to kind of interpret what that was. So because there's a camera in there, we can actually do that. So another idea is not to just have the QR code words on there, but to allow people to put notes or objects or things and have them as part of the poetic interface as well. So I think, yeah, it could work for music or for images, but that's kind of further distant. Yeah.
Let's everyone thank John for a great talk.
Thank you.
Okay, next up, we have a paper on analogy from Sturgis Apenthenis, Henri Prad, Gilles Richard, Leonardo Cortez Bernard. And it's Sturgis who's going to give us his talk on analogical proportions and creativity, a preliminary study.
Yes, it is indeed preliminary. keep this in mind. Okay, so I'm new to creativity. I don't know much about creativity, but I always had an interest on analogies. We know that there is a relation between analogies and creativity, so I would like to explore it. And so we started with analogical proportions. So in this paper, in this presentation, I'll present, it's really a preliminary study on how to use analogical proportions and what role could they potentially play in creativity. And we will further present a small study on how what we propose can be transferred over to LLMs and see what we can get. Okay, so what are analogical proportions? So in terms of analogies, there are many views. One of them is the analogical proportions, which has been initially introduced by Aristotle and has then been formalized in logic. So if essentially analogical proportions, they're expressed in the form of A is to B as C is to D. If we present them in logical form, we get this formula, which essentially expresses the fact that A differs from B as C differs from D, and B differs from A as D differs from C. So this can allow us also, if we have a triplet, for example, A, B, and C, by analogy, produce something new, which potentially can be creative or not. It remains to be seen. So this is the basic idea. You can imagine this, that our end goal is to have, as Tony presented initially, a symbolic system which can guide creativity, and then you transform what it proposes into something that can be used by an LLM and then produce text, which could potentially be creative. Okay, so in terms of analogical proportions, there are several postulates that need to be, of course, satisfied. Analogical proportions are reflexive, so A is to B as A is to B. This should be true. There is symmetry. If A is to B as C is to D, then C is to D as A is to B. And there is also the postulate of central permutation. It's not always, so this says that if A is to B as C is to D, then A is to C as B is to D. And then there are several consequences. But we were mostly interested in vectorial form vectors instead of just Boolean variables. So what happens if our A, B, C, and D are essentially vectors of Boolean values? When will we have an analogy? We claim that we will have an analogy if each term of the vector, for each term of the vector, we have an analogy. So we have to have AI should be to BI as CI is to DI for all the I's. So if this is true, then we have an analogy. So in this way, we can create a new D given a triplet based on analogies. And of course, there's stuff that we cannot see here. I don't know why. Okay, should be like this. Okay. And of course, if we go to real valued vectors, then we can take the geometrical view of analogies that has been used in the literature as well. So what we should have is A minus B should be equal to C minus D. In this case, A, B, C, and D are analogous. Okay, so how can we guide creativity? If I can change this. Okay. So if we have an initial set of items which are of course described by the same set of Boolean attributes, so the goal is to have a procedure that can allow us to create new items based on the previous ones. So how can we do this? We can focus on a specific instance C, then take all the pairs A and B, and see and examine if for a given C, which pairs A and B produce a new instance X based on analogies. And then see if, I mean, in terms of creativity, see afterwards if this is something that is creative. Now it might, so essentially what we say is that if a property is gained, so we suppose that those vectors, with 1 we encode the interesting features and with 0 the non-interesting, let's say. So the goal is to accumulate more interesting stuff. So what it says here, what we do essentially is that if a property is gained or lost when we go from A to B, and C does not have this property, then this property is also gained or lost when we have the solution X. And if there is no change from A to B on attribute I, then X just will copy the value that we had before. Okay, so it might be the case that we do not produce enough solutions because our initial set is not big enough, or that the solutions that we created are not that interesting. So we should consider a way of enlarging our initial set of vectors and see if we can somehow guide this creativity. How can we do this? There's an operator that my colleague Henri Prade and Gilles Richard, they have introduced in another paper. So we can use this. So essentially, if I take 2 pairs A, B, and C, D, with this operator, I can produce a new instance, which is a conjunction of A and C and the disjunction of B and D for each component, of course. And this can create new instances, can give us new instances of new pairs, which we can then use to enlarge our initial data set. And again, afterwards, use the same mechanism of analogies in order to produce new instances. Okay, so this is basically a mechanism which allows us to introduce new instances based on analogies. The thing is, how do we use them? Well, as I said, it's a preliminary study. So initially we said, let's take a simple data set that exists somewhere and see if we can do something interesting. Our goal is at a later point, we're actually working right now on a way to produce stories based on this procedure. But for the moment, it's just a small experiment that we did. So the idea here is we used a small database which described animals. It had just 101 animals which were described by 70 features. So for any triplet of vectors that we had in this database, what we did is that we tried to find a new instance X for each triplet, such that, of course, we should have a solution. And then the central permutation should also hold. And then we try to transpose this onto real vectors. I will show you afterwards with this equation. So what did we do? So we calculated all possible triplets. We could work on any subset of features and focus only on them and see if this gives something more interesting than another subset of features. Or we could work on all 16. So but working on all these features is computationally prohibitive. So what we did, we kept the 15 features, all the 15 features, or we just took a small sample of 5 features and see if this could give us something interesting. So what did we do? With a symbolic approach, what we did is that, so again, we took all pairs, we created new instances of animals, at least animals that had specific features according to the analogical procedure. And we tried, so we don't know how to evaluate. How do you evaluate these things? So we said, can at least our method identify some of the animals that exist already? Of course, it might have produced novel, interesting animals with crazy features, but we didn't have any way of evaluating this essentially. So at least we said, can it identify existing animals? And of course, when we keep all the 16 features, it's the precision is 22.64. When we used only a subset, it goes up. Yes, so then we wanted to see if we use embeddings, can this produce something interesting? We used globe embeddings initially. So for each triplet, we calculated X with this equation. It's the geometrical interpretation of analogies. We found the closest word to this vector using the Euclidean distance. Using wordnet scene sets, we excluded the words that were not animals, and so we kept only the animals. And so this gives you essentially a ranking of the GLOVE vectors that represent words. And so we saw that if we give the precision at 8, GLOVE can, as the K increases, GLOVE can propose animals that exist in our database. So then we also wanted to see what happens with when you use contextual embeddings. The problem there is that if you have so we said we will create a sentence that describes the animal given the features that are in the database. So we created sentences like this. We could get for the sentence embeddings for each animal. The problem there is that you cannot go from embeddings back to sentences to see which sentence is closer, and then okay. So what did we do? So essentially what we did, the first thing that we did is that for each triplet that we have, this triplet also provides a symbolic prediction. And then what we did is that for each, we calculated the Euclidean distance, and we saw that BERT is not that good, essentially, in identifying animals that exist already, at least with our method. And then we did further experiments where we tried to compare. So we said, okay, maybe information on because we used the animal name here, so maybe this guides BERTs, and effectively, if we remove the animal name and we just give the a description of the animal that does not contain the animal name, then essentially comparing to the symbolic predictions that we had, the results get worse. I will not go into the details. So yeah. So this is, as I said, it's just a preliminary study. It doesn't tell us much, if you want, about creativity for the moment, but our goal at some point, so we can have some initial conclusions that we can identify with GLOVE animals that already exist, but at least with the approach that we had when we use contextual embeddings, we do not get animals that already exist. But this is just a preliminary study. It has many, many limitations, of course. But it also has some promises in the sense that the ZO database that we use is quite limiting. We should expand this. So what we are working right now is on a way of essentially guiding an LLM in order to produce stories that will mingle together based on analogies, several dimensions, like, for example, emotions describing the same text. So it's that's what we did. And of course, the big question is how can we evaluate in the end creativity? And of course, this conference was very helpful in making me understand how we can evaluate. And there's no consensus, but it's interesting to see all these opinions. So that's all from me.
We have a question.
Thank you for your presentation. So I apologize in advance if I missed something, but I wanted to tell you, are you familiar with the analogy tests like those introduced by Mikolov like 11 years ago? Okay, so do you think that this method that you're proposing can be combined with that kind of analogy tests to like evaluate if collection of embeddings can be used to produce some sort of creativity in the systems, like to assess in advance if a word embedding set is going to be fruitful for the creativity of, for example, transformer-based model trained with previously initialized vectors.
So what you are saying is whether we can evaluate somehow a set of words, the creativity of how can this, well, yes, an idea would be, so by analogies or by itself?
Yeah, as you have the analogy tests, like the classic ones, maybe you can have another version that you can propose, like to evaluate the power of creativity in those embedding collections.
You could. The thing is that you have to measure it somehow. So you
Yeah.
have to have an idea where exactly will you use it as a task, which will allow you afterwards to give something measurable. So there are many ways that you can use your initial set, produce by analogy something new, and of course you can. So analogy is a vast subject. So in each one, many researchers see analogies from a different viewpoint. So one of them is the analogical proportions. It doesn't mean that it's the best way to view analogies. It's an interesting way. It can give you lots of things, but it's also more of a cognitive phenomenon in the sense that analogies allow you to create abstractions to compare to other things. So in my view, in order to evaluate, as you say, the creative power, let's say, of a set of words, you have to have a specific task that you want to do in the end, which will allow you to measure this thing.
So like an extrinsic evaluation.
Extrinsic evaluation, exactly. Evaluating them intrinsically, you can say lots of things, but it's what Tony was saying the other day also, that they have to be somehow useful. So you can evaluate novelty, you can evaluate many things, divergence, whatever. But if you want to see that, if you want to measure somehow how interesting, how really useful they are, you have to devise a task in the end for which you can measure this, measure the usefulness in it. So you can have a baseline that does not use analogies, for example, and then introduce analogies in your approach and measure the effects that this will have on your task. And if this increases your performance or it increases something in there, so people use it and then they get something interesting out of it, or if it's a task, it increases the results of this task, then not only can you measure the creativity part in the sense of novelty, divergence of your solutions, etc., but also how useful it is. So you have to have both. I'm strongly convinced on this. After attending this conference, I think it's the most important thing that you have to measure both, actually.
Thank you. And thank you for your presentation. I really liked it.
Okay, we have to move on. Thanks again, Sturgos, for a great talk. Up next, the talk is Creativity and Markov Decision Processes, harking back to Dan's talk earlier today. And the authors are Jonas Lahikanen, Nadia Addy, and Christian Guckelsberger, and the talk will be given by Nadia. Thanks.
Okay, can you hear me? Excellent. So my name is Nadia. Thank you for introducing. And Jonas is over there. And we are from the Autotelic Interaction Research Group at Aalto University. Christian is extremely sad that he could not make it, but he is a fresh dad, and that's the case. So this community, centered around computational creativity, has brought forward some amazing work on the analysis and evaluation of creativity. In particular, a number of works draw on psychological theory to develop formal frameworks to evaluate systems' potential creativity. These formal frameworks offer opportunities for us to assess a system's creativity through theory, supporting our understanding of how creativity might be exhibited by a system and how we might foster creativity in future systems through engineering and design. Now, as AI has progressed in recent years, creativity is attributed more and more often to systems across the larger AI research field, beyond work specialized in computational creativity. One of the most well-known examples may be AlphaGo. Well, there's always technical difficulties with this sort of thing. Sorry, I wasn't used to presenter view. Can we? It's playing from the wrong spot. I'm so picky. 5210. I have a very specific plan here. We do it over here? No. Okay, here, let's escape out of this mode. Can I escape? Okay, let's try that. And then let us, maybe we'll play it this way and oops, right. Ah, man, I was just like, I'll make it bigger, it'll be fine. False. Okay, so, all right, so we have an example. People are calling AI systems creative. Attributions of creativity, however, are usually based on intuitive judgments and are not necessarily theoretically grounded. So while intuitive judgments remain a really valuable source of creativity evaluation, we also believe that structured and theoretically grounded accounts are at least equally important for supporting scientific progress. However, despite their availability, formal frameworks are rarely used. Of course, in the design of most AI systems in the wider AI community, the formalization of a system in terms of a creativity framework is rarely involved. The designers of an AI system at large aren't usually thinking about creativity during their design process. And then post hoc decisions about how a given system fits into a creativity framework would typically involve both sort of interpretation, effort, expertise, and it may introduce inconsistencies as different choices are made along the way. However, this is computing, so of course, mathematical formalism is pretty typical, but it's just not creativity formalisms. And in particular, many AI systems are viewed as solving sequential decision-making problems. And one favored way of formalizing such problems is in the form of Markov decision processes, or MDPs for short. Some of the most well-known advances in AI have rested on algorithms developed to solve Markov decision processes. And while these big headlines are all centered on games here, I don't want you to mistake this for a framework that is only used for game playing systems. MDPs have been used to formally describe the problems faced by, say, a recycling robot, or to determine the moment-by-moment decisions of stirring rate and temperature for a bioreactor. Any problem that requires sequential decisions and where the best choice depends on the current context or state, which changes over time, has the potential to be modeled as an MDP. As a result, MDPs are used commonly across multiple research fields, even beyond AI. This itself offers a great opportunity. A formal mapping between agents in interaction with Markov decision processes and a creativity framework would immediately allow for the standardized analysis of numerous artificial intelligence systems in terms of how they might be considered creative. And so developing such a mapping is actually what we set out to do in this paper. So let me give you some intuition about what I mean by formal mapping. The formalism of MDPs allows us to view an agent interacting with the world as a handful of mathematical objects. I'm going to use some non-standard symbols here because I don't want you to get caught up in what they mean. I just want you to get through what the process is. And so let's assume we have a creativity framework that similarly deals with a handful of mathematical objects, but this time they're different ones. So they have different required properties and different meanings. And we want to build a formal mapping that can take any instance on the left side and take combinations and transformations of the objects that it's composed of to form an instance of the kind on the right. Each of these new objects have to have the right properties to fit into the creativity framework. If it's a reasonable map, it's going to allow us to understand any agent interacting with the Markov decision process as the type of object that we can appropriately analyze with our creativity framework. So I'm going to get more concrete as we go along, but I wanted to start off with the intuition. So our formal maps take objects of one type and they allow us to understand them as one of the other. But of course, given the wealth of ideas from the computational creativity community, where do we focus this paper? For this work, we focus on Margaret Bowden's process theory of creativity. We chose Bowden's theory because it provides theoretical means of distinguishing different types of creativity, different opportunities for creativity, and different obstacles to creativity. And unlike quite a number of other theories of creative processes, it doesn't assume the need for creative faculties that a human would have. Additionally, Bowden's theory has this advantage that it has already been formalized, giving us a stepping stone for mapping between Bowden's theory and MDPs. In this paper, our formalization of interest is the creative systems framework. This may seem familiar. And it is by Grant-Wiggins and then later reformulated by Graham Ritchie. So we've already seen the CSF in Ika's talk and in Dan's talk. Ooh, I've lost Dan. But I'm going to give my own take on it here, hopefully to support your understanding if you're not familiar with it. So Grant originally formalized Bowden's theory, which gave us a really cool concrete interpretation in set theoretic terms. And like Dan, we particularly end up relying on Ritchie's simpler reformulation, which additionally extends that framework. The creative systems framework, beyond providing a concrete interpretation to map to, extends Bowden's account and provides additional theoretical tools. So the central model in the CSF is the exploratory creative system. An exploratory creative system traverses the universe of all possible concepts, and in doing so, it has the opportunity to land on concepts that might be considered creative. An exploratory creative system is composed of 4 objects. So the first is the set of all possible concepts that the system could ever access, which is a subset of the universe of all possible concepts. And we call the set P the subuniverse. The second and third objects are the acceptability, let's get to that, and the evaluation functions. Each of these functions maps concepts in the subuniverse to real numbers between 0 and 1. The output tells you how acceptable or how valuable a given concept is to the exploratory creative system, respectively. And the last object is a traversal strategy, which determines how the system traverses from groups of concepts to groups of concepts. To design a given map to the CSF, we have to decide what sets should be the universe and the subuniverse, and what should be the acceptability, evaluation, and traversal functions. In this work, we followed a 2-phase procedure, first generating multiple candidates, and then evaluating them to select the most promising. Specifically, we first generated candidates focused on what we thought would be appropriate to understand as concepts. And so I'm going to show you our 11 candidates that we used. I don't want you to worry about what they mean for this presentation. If you're interested, there's more description in the paper, but we really did focus a lot of our work on further developing the ones that we thought were most promising. To understand our mappings, I think it's useful to see how Markov decision processes model sequential decision-making. I've already covered the creative systems framework objects, and so now I want to cover the Markov decision process objects. In a Markov decision process, we imagine that there is an agent faced with an environment. This agent might be a game-playing system, it might be our recycling robot, or any other system that needs to make decisions in the world. At any given moment, the agent has access to context with which to make a decision. We call this the agent state, and it comes from the environment. So, for example, for a game-playing program, the placement of the stones in a game of Go might provide the state, and then the agent needs to make a decision choosing an action. So they receive immediate feedback that's a reward and a next state. And the problem is that it needs to learn how to accumulate the most reward over time. we kind of simplified how the agent does this down to oops, I've lost this. Okay, so we've got state, I'm going to zoot through this because I think you get the idea. We have the set of states, the set of actions, the set of possible transitions and how they work, and then we have the stochastic reward function. So, and then how does it solve the problem? It comes up with a policy that decides what it should do next depending on the current state. And we call that pi. And so basically our mappings take a Markov decision process paired with a policy and map it to an exploratory creative system paired with a universe set. Hopefully you can see how this will allow us to explore creativity and decision-making across numerous settings. So I don't have time to walk through the mappings, but to show the depth of the paper, I do want to show our compact table that sort of lists how we've done the mappings. And additionally, we follow through to explore the implications for other concepts in the creative systems framework that are derived from the exploratory creative system. And so please come talk to us later if you want to go into more depth. Now, with the remaining time in my presentation, I want to give a quick advertisement for the other remaining contributions in the paper besides the mappings themselves. So the first contribution is an argument for MDPs as a minimal framework from which to map Boden's theory. And we essentially argue against using Markov processes, which are a simpler model from which MDPs are defined. Basically, we get rid of the decision, getting rid of the actions and the rewards. So we're just left with the states and the transitions between them. What's missing here, though, is something that is an appropriate notion of value. And so value is really important to Boden's framework, and it remains quite important in the CSF. And so it doesn't make sense to take any combination of the set of states or the transitions to do that mapping. Now, the next contribution is a discussion of which types of creative processes, uninspiration and aberration, could be observed in a Markov decision process under the three mappings that we detailed. Uninspirations and aberrations are really important, Dan mentioned as well, to Boden's original theory, and they're detailed in the CSF. So the final contribution stems from important questions like, how do we choose between the potential mappings since there are so many possibilities? How do we know if a mapping is a good one or if it has potential issues? At the end of the paper, we propose 4 different quality criteria, and we apply them to the mappings to look for issues associated with the mappings. These include semantic similarity to the original theory, functional similarity to the original formalism, compatibility between the two frameworks, and applicability across diverse AI systems. While there's certainly room for expansion in these areas, I think it's also useful potentially for mappings between other psychological theory and frameworks. So this is well worth exploring. Now, we're not the first team to do this kind of mapping. Back in 2016, Thomas Collin led a team doing pioneering work between the creative systems framework and hierarchical Markov decision processes. Their work is really different from ours, but I think it's really worth taking a look at because it provides a pretty fascinating analysis and an important piece of context for this agenda of mappings. So our team of authors really only came up with this one particular very related work. And so we really wanted to ask the community, what are the other papers that we're missing? Because there might be other people doing these kind of mappings, especially with creativity frameworks, and we would love to know if you've come across them. And so there's a great deal of potential work suggested by this paper. For one, we can explore potential implications. We can map to real life systems and see how it applies there. And we can extend MDPs the same way that Collin and team did, looking at maybe partial observability in other areas. So given this breadth of potential future work, we see this paper as not concluding, but rather opening up an interdisciplinary research agenda, where we hope that we can establish a new formal basis to strengthen the dialogue between computational creativity and psychology with AI research at large. So both Jonas and I are more than happy to answer questions. And if you don't catch us today, since I know it's the last day, send us an email and I'm happy to talk more. Thank you.
Questions? We have a question. Man in front of bright light.
Yeah, thank you very much for this. This is great because, yeah, I'm doing some work. I think there's a lot of relationship to what you're doing and what you're advocating. Yeah, so I was curious about So do you think that this is enough? So you're saying that this is enough to Markov processes may be enough to model creative behavior?
So we said Markov decision process, or sorry, Markov processes, not enough. We could not find a way to do that appropriately.
Okay.
Markov decision processes, we found some ways, but if you look at the paper, when we go through the quality criteria, there's places where we're like, oh, this isn't going well. Like there's a bunch of things that are either like very boring or like kind of just like it just doesn't quite work out. And so I think we need to do more like further work.
Okay, yeah. So one of the things I've been thinking about is about memory, and I think Markov is a lot about that, from the Markov property, right? So my question is, do you think that's a limitation of Markov processes, or is that not a problem to model creativity?
It is both a limitation.
Wow, is it okay if I turn this on? Thank you.
It is both a limitation, but it is also good in the sense that we are not limited to systems which have a memory. So we can it might be more easy to apply this kind of general system to systems with memory, but we also acknowledge this might hurt the kind of applicability to like diverse AI systems where the memory is very essential to the creative process, which is probably the case in many areas. But so yeah, it's a difficult balance.
It is. Yeah. Thank you.
Yeah, I think it's a really interesting thing to explore further.
We have time for a quick question. Okay, you might have thought of one by lunch. Let's thank our speakers again. Okay, the next talk, the last long talk in the session before we go into the short talks. No, that's not implicit press. Yes, it's the last long talk. I mean, savor it, everyone. It's by Murray McKeach, and he's going to talk about how generative computer systems can mitigate common cognitive problems of creative practice. Take it away, Murray. You take this.
Hello, everybody. So this is really the only opportunity I get to say hello to everybody, almost everybody at the same time. So if we haven't met formally, hello, Murray. And I've got to say, I found this community incredibly, warm, open, and it's been a real pleasure. This is the first time I've been to this conference, but hopefully it won't be the last. It's been a real pleasure. Anyway, I'll get stuck into it. Okay, so I'm going to be talking a lot about some of the bad things about traditional creative practice, because this is what led me into generative practice. It was a very organic thing. I spent most of my life as a working artist, and I was reasonably adept at traditional media before computers. I spent a long time as an illustrator and art director. I moved into computers in the 90s. Let's have a look and see again. This is the kind of thing I started doing. I moved into like photo montage. I'd have these photographic elements and, I put them together into composite images. But still a traditional way of working. I'm putting these things together piece by piece, bit by bit over time. A process of incremental accretion. And I loved it. I mean, I loved getting onto computers. I was pretty good with paints and pencils, but, I actually fell in love with Photoshop and, I was able to do these kind of wonderful images and really enjoyed it. However, at some stage, things got harder to do this kind of work. Basically, I started having children, and I had far less time for this kind of work. This is very time consuming, putting together something like that. There's 4 images there, but my finished images mostly got maybe 20 or 30 different images, and they've all been crafted together. And this is what led me into generative art, very organically. I didn't even know that I was doing generative art. Didn't happen immediately, but there was a process involved. I've used this as, these are 2 magazine covers, so it's kind of like a baseline because it's the same magazine. We can see in here in 2000, They've used an image of mine which was put together in a very traditional way, traditional photo montage in Photoshop, piece by piece, step by step. But then if we go forward 7 years, that image there was completely created through a generative process, and it's one of a batch of thousands that, you know, I kind of produce and then choose the exemplars out. The interesting thing, or the great thing for me, was the fact that the editors of the magazine weren't particularly interested that it was generative. They still just assumed that it was my content. So across that period, I was able to move my traditional process into a generative process, and by transcribing my kind of style and a lot of the kinds of decisions that I made into an automated kind of process. So, and I fell in love with this way of working, and I haven't looked back. It's the only way that I work now. I work generatively. I don't go through that process of creating things step by step, piece by piece anymore. So what I want to talk about today is how did generative computation make creative practice better for me? So I'm going to be looking at some of the negative things about traditional practice. Because believe me, if you've worked as an illustrator and had to try and make a living out of it, it can be grinding. It's hugely time consuming. And that's one of the reasons I fell in love with these kind of automated processes. So I want to start off with this. By the way, what I'm going to talk about is incredibly kind of reductive. A lot of people get upset, especially when you're talking about art and creative process. There is as many creative processes as there are artists. And of course, famously, it's been impossible to come up with a theory of art. So it's one of those areas where it's very easy to kind of upset people if you're being reductive. However, there is, as I will show you, there is at least on one level, a very kind of basic level that's shared by almost all creative practitioners. We think of an artwork, say a book, a painting, or music as a whole, but of course, we look into it, it's made up with these basic, very basic elements. Words, paint strokes, music notes. Almost every form of practice has these basic elements that are used to construct it with. There are some exceptions. You could argue that a lot of conceptual art or straight photography, those kinds of things, but it's most forms of more mediums of practice are these kind of basic kind of elements that are used to construct the work. So most art making a process of building artwork piece by piece, step by step. And this is, of course, by a human agency in a traditional model of practice. Alternatively, computational agency in a generative model. So if we take all those little pieces and we get here kind of like a model of building an artwork, it's just step by step, piece by piece over time. It doesn't matter what your idea is, doesn't matter what your creative process is, somehow it has to translate down into these little elements, the words, the paint strokes, the elements across time. Of course, I'm using the analogy of a book here, but you know, those things kind of then form more abstract concepts like the sentences, paragraphs, chapters for a book. And you can say this with other works as well. That kind of structures emerge. Now, if we look at each one of those little steps when we're constructing an artwork, we could say that each incremental step of accretion has three parts. So conception, action, and judgment. In very rough terms, it's some conception, what it's meant to be doing. The actual action of doing it, we're making the mark, and then some kind of judgment. Because when we add to a piece of artwork incrementally, we're changing the construction, we're changing the overall effect, and there's usually some kind of feedback loop between the artist and the work underhand. However, these steps, there's literally thousands of them in most works if you take it down to that level of individual notes, words, and brushstrokes. And so most of them are made automatically or with very little conscious attention. So we could think about it as just this, you know, conception, action, judgment. And a lot of it is just instinct. When we learn the craft, we don't have to think about every word or every pencil stroke. A lot of that just becomes automatic. And a lot of that repetitive decision-making actually defines a person's style their style of thinking or the style of decision making. We have to remember each one of these things represents a decision. The point being that a lot of this is unconscious decision making. So basically the work that I provided. Now I'm going to be going through this very kind of quickly, and I'm going to go through it on the basis of how it affected me personally as an artist. But in the paper, there's a lot more detail with from art history, cognitive science, and other. We go into a lot deeper in some of the areas that I'm covering. For me personally, when I'm making this transition from traditional to the generative practice, I thought very long and hard, well, why do I love this? Why is it better for me? Not only am I making work quicker and better, quicker, but it's actually improving the creativity as well. And after a lot of kind of thought, it came down to this incremental thing. This is where a lot of the problems of practice come from. This granularity. It's hard to get away from. If we compare that, this traditional art making, we could say very broadly, generally, this perhaps generative art making, where this kind of, the conception gets all front-loaded when we build the system. Of course, the process creates the work, and if we're not intervening at any stage, we finally have the judgment function at the end when we're looking at the output. And of course, what we're doing, we're taking all these little bits of conception and everything and putting them, front-loading them into that the design of the system. So now I'd love to talk more about the things I love about generative art, but the point of this exercise is to explain why, for me anyway, and I think potentially a lot more practitioners in the future, is that these are very real problems of creative practice in a traditional sense, which come up again and again across history and across cultures. And as I said, my paper's got a lot more detail in terms of references and account and cognitive science. So of course, the first one is just that productivity and aspiration. Now we know that quantity does not equal quality all the time, but there is a lot of evidence that your ability to quantity increases your creative productivity if you're experimenting. And we have a very limited, amount of, waking hours, the ability that we have to concentrate. Some people say it's like 5 or 6 hours for any kind of expert to concentrate on what they're doing optimally. So of course our physiology is limited. So that was the first thing. I'm going to work through this. Habit and formula. Now, of course, because most of the decision making is automatic, habit and formula kind of get, it's very hard to break out of. So the micro plans of accretive authorship are so many and constant that they often escape the conscious deliberation and awareness of the artist. It's got to do with skill building. So this is one of the things that makes traditional art practice very hard for people to change style and to move out of their particular thing. This is an example, Bridget Riley, a painter, explaining why she used studio systems. She needed to distance herself from brush and paint in order not to fall into the trap of formula. Now, another thing is reduction and convergence. When you're creating a piece of work traditionally, bringing up, like as Gerhard Richter says, bringing the painting's elements into relation become more and more difficult the further the picture has progressed. So you've got all these elements, you're keeping them, you're working towards something, keeping them balanced, and there's a tendency quite often for it to slow down as you're getting towards the end of it. It can become, to try and, your potential is collapsing as you kind of zeroing in on the final thing. Something, of course, which can be ameliorated using the generative processes. Conservation bias. So there's a lot of the heuristics that we use to create artwork have got the nasty side of the bias as well. So there's a lot of things like sunk cost bias. The more work you put into something, the much more likely are you're going to make suboptimal decisions just to protect that sunk cost. The Goldloom's large effect too is quite interesting, where you know there's inhibitory processes which will stop you from taking risks, just because the mind's trying to protect this the sunk cost of energy. You can see it from Chuck closer. I keep working so they never have to take a break, look at the work, and be critical of it. Which leads us to one of the things that the generative processes are really good at. These kinds of creative strategies, like the deferral of judgment, limited commitment mode, resistance to premature closure, and tolerance of ambiguity. Now, these are all methods and strategies which have great creative potential and perfect for generative systems as a way of avoiding the kind of cognitive biases that you can be prone to. Objectivity and subjectivity. Paul Gauguin, it's true that one is not a good judge of one's own work. In fact, actual fact, he was quite an egotist. He thought he was a really good judge of his own work. But this is a common thing that you hear from. It's very hard to remain objective about a work that you've been working on for days or weeks, whatever. You can suffer from semantic saturation. Same process when you say a word over and over again, it loses its meaning. This is one of the nasty byproducts of working on an artwork very closely for a long time. Of course, with the generative process, I pretty much see my works completed almost like as an audience member. Another thing is authorial distance and intimacy. The values of expression and representation in art often depends on the artist disappearing from his or her work in some way. So this is quite an important aspect for a lot of creative people, to disappear from the work, unless you expressly want to be seen in it. That illusion of creating another reality. Sometimes you just you want the authorship to disappear. You don't want to see the author. And so in this case, generative processes are fantastic for that kind of getting yourself out or removed from the work, which is actually very important in a lot of cases. I mean, the minimalists were trying to do that as well. They were trying to take it. Well, the expressionists were all kind of going off and being incredibly, putting their souls into the canvas. Solarwit wanted to get us out. He wanted to do something far more mechanical. But it's just one example of that kind of authorial distance and being an important aspect of creative process. The final one is a little bit kind of, I suppose, it's a little bit more kind of, I really do believe that you can make an argument that generative computational processes are in some ways, important ways, more human than traditional ways of working. I mean, I really honestly believe that. It's because of that gap between conception and the experience of an artwork. You don't have that kind of breaking it all down to those little bits in between. There's like a far straighter kind of line. Within Collingwood, that's what I imagine, however complex it may be, is imagined as a single whole, where relation between parts are present simply as qualities of the whole. So for me, at least, I've got that I have the idea, create the system, see the output, and it's a far kind of more natural line between this conception and realization. So I think that's an important thing that I've got from the whole process as well. Am I going for time? Great, excellent. Here we go. Thank you very much. Now, I would have liked more time to share some of my actual work, but unfortunately, if you look me up online, you get to see some. Anyway, questions? Yes, right.
Thank you. That's quite interesting to see your personal experience on this whole process. I'm wondering, like, it seems to me there's some sort of dependencies in the action and conception, and you sort of take that out in that graph that you have there. And I was wondering, if you look at your whole body of work, if you experience a divergence or convergence in style because of your work with these generative processes.
What's that I didn't cover too was in one way, there's plenty of objections to this. You've just taken the process of creation from individual work over to the system, because you're building the system in the same way. But I think there are some very big differences, and it's with the creation and the modification of systems that I evolve creatively now, and they're always in this constant state of evolution. One big difference is that creates a lot of what is previously tacit knowledge that becomes explicit in the system. It's a very big point. It's a lot harder to try and modify your psychology. It's a lot easier to modify where it's quite explicit. But there is, and there's something in there. But from a practical point of view, I've found that I still have a creative evolution. But,
All right, thank you.
You have a question, Murray? Yeah, Maya.
Very short question. You said you have artwork that you can show us.
Oh, I have to go off the reservation, but
while you're looking it up, can you briefly tell us what kind of techniques you use? Are you using scripting tools or are you using code generation?
no, I'm terrible at code. I started off with just using macros in Photoshop. Then I moved over into After Effects where I could use JavaScript. And sorry, I did have something open here that I was going to show people. But of course, it's gone all haywire on me. So actually, I use off-the-shelf software. I use After Effects, Adobe After Effects. I'm terrible when it comes to any kind of programming or coding, but I do know enough to put together a bit of JavaScript, use the randomness, and so quite often I've really just hacked existing software, and it's grown very organically. I did have but my computer's gone, unfortunately. Anyway, I mean, just Google my name, you'll find. So I don't have. I'm sorry. I've got. And I'm kind of ashamed and proud to say that I've never had a website. I've never put a website up, but there is stuff out there that can, So yeah, I use photographic material. I use Adobe After Effects, and I use. Usually, I put together. Outputs of, I always measure it to how fast I can go through a set of outputs to, in an afternoon. So I'll limit it to maybe, 5,000 works or whatever. And the way that the systems have always got that kind of parametric controls built in. So what I'm trying to do is with the system is fine tune it so that, it's that kind of the noise ratio. I'm trying to come up with something surprising. But so I'm aiming at the middle, but I know the good stuff's going to come up from the periphery. And I love that saying from Gomber. It was like aesthetic pleasure lies somewhere between boredom and confusion. And so the systems I build try to get that hot point between boredom and confusion.
Well, thank you, Murray. Let's everyone thank Murray again.
Share your screen.
Of course. So next up, we have a series of 3 short talks. And the first is by John McCormick, and Tace McNamara, The Creative Act of AI Research.
Here you go. Thanks again, Tony. And yes, this is work that I did with Tace, who's unfortunately not here, but made a fantastic contribution. So to get into it quickly, has anyone read this book? Oh, that's disappointing. Okay. So basically, this is a book by a guy called Rick Rubin, and it's about creativity and being a creative person and what it is. And I think everyone here who's into computational creativity, I would recommend that you read this book. I don't get any shares or royalties from reading it, but I think it's a really interesting perspective. I'll talk very quickly about what it's about and why I think it's interesting to consider some of the points that he makes in this book. This is not a quote from Rick Rubin, but it's a quote that he uses in the start of the book. It basically sets the stage for the rest of the book. He's not interested in making things, in producing things. He's interested in being in a state that makes producing those things natural and inevitable. And I think as a creative person myself, as a practicing artist, I really like this way of thinking about creativity. So the paper is, I'm addressing this to, when I say I mean you. Why should you be interested in reading this book? I think there's two reasons. Firstly, it's a really fantastic way of understanding how one of the most successful artists of our age views creativity and the creative process. I'll talk about who he is in a second. And secondly, as researchers in computational creativity, how might we approach developing creative systems? Because after all, as researchers, we're creative people too, right? To be a really good researcher, you need to be really creative. Okay, so what is Rick Rubin's view of creativity? It's hard to summarize in a single slide, but I'll try and do that. Firstly, that being creative is part of being human, so everyone is creative. Being creative involves opening yourself to a way of being in the world. So it's trying to attain a particular state. In the way that you do that is to attune yourself to your environment. You receive information, you filter that information, and you curate information and experience for yourself and for others. And I guess one of the key points is that generating artifacts has very little relevance to being creative in his view. So who is this guy, Rick Rubin, that I'm rabbiting on about? Well, I've got actually two people here, and I'll explain why in a second. So Rick Rubin's a producer. He's produced like the Red Hot Chili Peppers, Adele, Johnny Cash, everything. So he's not a musician. He's not a talented musician himself. He's a producer. He's the person who gets musicians to be creative, to get their creative best out of them. And I guess if you wanted to draw a parallel with someone, maybe Brian Eno is the closest analogy, because Brian Eno is a very successful producer as well. I mean, he's an artist, and also he's not very good musically, as far as I can tell. I hope this has not been broadcast. But this role is really interesting, right? Because it's people helping other people. They're facilitating creativity, but they're not necessarily super creative in their own personal practices. And I think that's a really interesting observation. I was just going to use this analogy here. Many people know about Brian Eno and Peter Schmidt's oblique strategies, which is just a collection of really simple card instructions that they developed in the 1970s. And it still remains it's in its, I don't know what edition it's in now, but they keep adding to it as well. So the key thing is that these people like Rick Rubin and Brian Eno, these producers, are creative facilitators. So what can we learn from this? I think, and because this is a short paper and I've only got 1 minute left, I can't really go into a lot of detail, but we looked at 6 different areas from the book that I think are really interesting in terms of how people could conceptualize creative systems, how they build them, and what they do. So creative facilitator is kind of an obvious one, a system that facilitates people's creativity. Critical listening and feedback, I think, is really interesting, because as a producer, you listen to what a band does or a performer does or a musician does, and you give them critical feedback, not in the binary sense of that bit was good and that bit was bad, but actually allowing the person themselves to explore their own creativity and to deliver a better creative result. Anyway, if you're interested, have a look at the paper. It's only 4 pages long, or even better, read the book. I just wanted to finish with a bit of a controversial statement, I guess. These are 2 statements, public statements, that were made in April this year by 2 very prominent people who work in creativity and AI. The first is from Mustafa Surli, who's the CEO of Microsoft AI. And he said, just a few years ago, people said that AI would never be creative, and yet AI now feels like it's an endless river of creativity, making poetry and images and music and video that stretch the imagination. And that's a very optimistic view of production, cultural production. Molly White, who's a really interesting blogger, has a completely different view. AI-generated images tend to suffer from a similar bland tone as its writing, and their proliferation only makes me desire real human artwork more. So these are 2 very polarized views. Personally, I side with the second view very strongly. But I think we're at a crossroads here, because there are there are more AI-generated images now on Earth than in the first 150 years of photography. And that's incredible over just a short period of time. So that's why I really need to think, we need to think about the kind of ethical responsibility of these tools, not just in terms of individual tools doing something, but their broader cultural impact, particularly in terms of just producing more and more mediocrity. And I think part of that comes back to thinking about what greatness is. And again, this is the last Rick Rubin quote, aiming at greatness is different than aiming to be better than someone else. So a lot of the big kind of AI breakthroughs are all about beating humans, like Lee Sedol getting beaten by DeepMind, people playing chess, machines can do it better. And now machines can make art and illustration as good or better than your average human. And I think that's a really inappropriate way of thinking about what greatness is. Greatness is about aiming to be different, not to better everyone else. So I'll leave you with that, and hopefully it's inspired you to read the book and the paper. Thank you.
So with this view of creativity being a sort of state of mind, as he said at the beginning, where does that leave systems that are not conscious but can exhibit creative behavior?
Well, I think that, yeah, that's a very deep question to try and answer. But I think the emphasis of the book is really about human creativity. And creativity, as he sees it, is a human thing. Now, of course, we can talk about other forms of creativity in machines, in nature, in the universe. But his focus is very much about what creativity means to you as a person. So it is a human-centric perspective, I guess. So that question would not be really relevant to him. I know I'm kind of trying to speak for him and just based on his book, and I can't do that. But he only has one point in the book where he talks about AI at all. And he does talk about the DeepMind beating Lee Sedol in there. And he doesn't treat it negative. He said he cried when he first heard about the machine beating him. But because of the way that it beat him, and it's in the paper we talk about, it's called Beginner's Mind. It's this, that the machine had this fresh view that wasn't encumbered by a whole legacy of bias and thought about particular ways of doing things and what's the right way and the wrong way to do something. So this idea of beginner's mind is something that he really tries to get people to promote, because as you get older and more experienced, you get stuck in your ways, and so you become less receptive to new ideas and new ways of thinking. And so adopting this beginner's mind allows you to sort of free yourself from those constraints. So it's a kind of mental instruction manual for you as a human to be creative. And I think in his view, human creativity is far, far more important than machines being creative. I don't think he would be really interested in that, except from exposing things about how you as a person can be more creative. Thanks.
Okay, well, let's thank John again for a great and provocative talk. So next up, in a moment, we have the second of our short talks, Characterizing the Creative Process in Humans and LLMs by Saravi Esnath. And take it away, Saravi.
Perfect. Yeah, thank you so much. Last day, last session, nearly the last talk, but it's still very nice to see so many of you here, and yeah, it's a pleasure. So I'm a second-year PhD student right now at Max Planck Institute in Tübingen, Germany. I actually come more from computational cognitive science, behavior science perspective. And I'm going to talk about briefly how you can characterize the creative process in humans and LLMs. But then I realized that, oh, I also had a poster, and a lot of you were already there. And I don't want to verbatim repeat myself. So I decided that let's be creative and try to connect over this past week all my observations on how behavior science can be used to facilitate or augment sort of research in computational creativity. So yeah, keep an eye out on the right panel. Great. So what do? We use a very famous psychology task called the alternate uses task, which is very simple. So you, as humans, are given, say, 3 minutes to brainstorm as many diverse or novel uses of a very simple object like a brick. And people can come up with various uses like brick as door stopper, brick as a exercise weight, or even something more interesting like brick as footwear. But we are more interested actually in the process perspective. So yeah, throwback to a lot of people who have been talking about process here. So how do people move in this space from one use to another use? So how is the process of brainstorming? How does that look? And that brings me to the first use case of behavior science, right? That is tasks. It gives us good, well-defined, validated tasks to study humans and LLMs maybe across on the same platform. So how do we characterize the process? There's some theory. So in humans, we say that there are deep thinkers and there are broad thinkers. So we call these deep thinkers persistent because they tend to give you a lot of uses in the same category before jumping to a new category. And we call these the more broad searches flexible because they keep on jumping to newer categories. Now the question is, what about LLMs? Are they deep thinkers? Are they broad thinkers? How are they searching the space? And that brings me to my second contribution of behavior science, which is theory. So there is certain theory we know from psychology, which can be used as a starting point, and we can take it from there. And that can help us make good hypotheses. That's okay. Oh, okay. Yeah, maybe now. Yes. So, so yes, how do we characterize the creative process? It's a very simple automated data-driven method, which I won't go into. But basically, we are able to characterize jumps in response sequences. So you can see that every time a category switches, we are able to code it as a 1 and 0 otherwise. And yes. So as for results, we see that, based on, so one more thing I forgot, based on how many jumps you're making, you can either be clustered as persistent or flexible. So we see that actually LLMs as well can be persistent or flexible, but they are very task specific and they are also very LLM specific. So for a certain LLM across all temperatures, they might be persistent, but the other LLM could behave differently. So what is the implication of this? Is that if there is a human who's a deep thinker, it might make sense to pair it with an LLM who's a broad thinker. And then it could be a good co-creativity application here. So this brings me to the third contribution of behavior science, which is tuning. So if you know more about the human and how a human behaves, you would be able to pair it better with co-creative AI systems. And for future work, like I said, I'm coming more from the computational side. Another very common application of behavior science is behavior modeling. So try and fit human data or LLM data to models. And if you try to not make them black boxes, then to some extent, you can compare across these models, understand how your AI system works, and then you can also probably learn how to improve it better. So that brings me to the last point on how behavior science can impact or help computational creativity, which I call tallying. Not the best word, but it had to be with T. Yes, that is everything. Thank you so much. The paper actually doesn't mention any of this. This is just something I did right now for you. But the paper actually talks about how we test a bunch of different LLMs, more than 100 actually, on this task. So check it out. Yes. Mic drop. Uh-huh. Yes, so it's a very simple approach. So we actually embed all the responses, and then we perform hierarchical clustering. And then using those hierarchical clusters, you can see on an example on the right. So for example, a cluster could be everything related to furniture. Another could be everything related to using bricks as anything to do with toys. And based on that, so we look at the response, we see which cluster it belongs to. If consecutive responses are in the same cluster, it's a 0. So it's a stay. And if they jump, it's a 1.
Yeah, but it's more like, so do you do this labeling yourself, like a
Yes.
human doing it? Okay.
No,
Or is it
it's all automated.
automated?
It's
Okay.
all automated, yeah.
Okay, so you have those categories already done
No, the
before?
categories are automatically identified
Okay.
from hierarchical clustering.
Okay, hierarchical clustering.
Yes.
Sorry, I missed that.
No worries. I didn't even say it. So
Yeah, you go. Stretch across through there.
Thank you for your interesting talk. I'm wondering, when you said that different LLMs work differently, how consistent this is, or does an LLM like switch between the broad and deep approaches when you prompt it again, or is it consistent that the one LLM always uses the same approach?
Yes, great question. So ideally, what we wanted is that if we can change the behavior just based on temperature, for instance, but it turns out that no, it's not very sensitive to temperature or any other parameters. It's quite consistent within an LLM for the same object. So if I say alternate uses of a brick, then every time you regenerate it, it will tend to have the similar brainstorming pattern. But if you change the object now, like instead of brick, say alternate uses of a bottle, then it could totally switch. So the LLM is consistent within a task, but not so much across tasks.
Thank you.
Yes.
And we can see a Dan approaching the screen. This is our final talk of the session and of the conference. It's given by the two Dans, and the Dan you see here in the colorful shirt is the one who will be giving the talk. Dan Ventura is his co-author, and the title, which is not yet on the screen, is Creativity: A Search for Small, Interesting Programs.
My goodness. What? Speaking of small, we were doing so well, and now we're lost. I'm at a loss. Can you? So what's the problem? It needs an account.
Wait, if I close this one,
I don't know what'll happen.
no, right? Can
Most features are turned off because we don't have a license.
Oh,
The question is whether we can still run.
Right, let's see.
Can we run a slideshow?
Yes, you can.
Even though we don't have a license.
Let's see.
It expired 5 minutes ago, I guess.
Okay, let me just make sure that it's running the presentation. Sure. No, it was not here. One second. Just do open presentation.
I'd like to officially declare that I hate computers. Thank you.
Okay, but let me just.
Can you switch forward?
Yeah, I need to share now. It's this one. Go. Now do it here and wait a second.
Yeah.
See if we can.
I'll do one click, then it works.
Oh boy.
Take it away, Dan.
Thank you. Can we give him a round of applause? Thank you. So I am standing between you and lunch, so I will speak quickly because I'm hungry too. So this is a paper that Dan and I did on creativity as the search for small, interesting programs. This is part of a trend of papers that we started a few years ago with my student Tiasa Mondol in 2001 or 2021. which is basically about a view of computational creativity that comes from algorithmic information theory, not from entropy, not from a lot of the other theoretical models we've talked about this week, but from understanding how information is related to the objects, processes, and analyses that we do in this field. The core idea of this field is that the value of an object connects to its algorithmic complexity. There's some sort of sense that an object is good if it is complicated and challenging to produce, not trivial or banal or like things we've been seeing all along. Similarly, the novelty of an object connects to its conditional algorithmic complexity. If you've seen a bunch of objects that are like something before, it's not novel. This is the origin of my question to Kaz from about 2 hours ago. My understanding of novelty is this one right here. In this paper, we connect our overall idea of using algorithmic information theory to CC by focusing on the creative search process framework of Wiggins that we've seen a few papers about already this week. The CSF gives an abstract and formal representation of how search works for creative artifacts, but it doesn't really tell us what it means to do a good job in the search process. You just get someplace that's good. And if you can get someplace that's good, that's awesome. And that means there's a huge space of possible objects that lead you from one object to another object to another object to a good object. And so what's the kind of search function that's a creative search function versus a not creative search function? And let's think about this a little bit more concretely with the sense of some actual games that you all might play. Tic-tac-toe isn't a lookup problem. The way that you all play tic-tac-toe with kids, and sometimes maybe win, you just have some very specific rules in mind that you learned when you were a kid that teach you how to play this game. There is a very small lookup table that you could write that talks about, if the board currently looks like this, you should do that. But you don't do that. You actually follow an algorithm most of the time. By contrast, if you play Wordle, which like I do, you probably realize that the right way to play Wordle, even if you don't do this, is to just look up a process so far in a next move lookup table. Certainly that's at least how you probably play the first rule, the first choice, and probably even the second or third if you think about it. For games that we think are a lot more complicated, like checkers, for example, it turns out that the right way to play checkers, according to Chinook, which wins the game, is to actually use something kind of like a lookup table. So we're sort of stepping away from algorithms and more into the domain of lookup. And so we say in this paper, you should focus on that actual search algorithm. That's the object of creative search. It's not looking for objects, it's the meta search of looking for interesting paradigms of algorithms. And in particular, in our frame, we imagine that there is a collection of objects in the domain that you're looking at. And then based on what you've seen so far, of course, you come up with the next object you're going to explore. And we focus on these objects that are the algorithms themselves, which have to be Turing machines and have to always halt and have to result in a member of the space that you haven't already seen. This causes us to think about this domain and scratch our heads a little bit and say, well, there's only a countable number of these possible Turing machines. Some of them must be good, some of them must be not so good. Which ones are good? And the connection to this algorithmic information theory frame for understanding CC is right here. We say that the kinds of algorithms for doing this search that are good in our framework are ones that are not very big to write down, fairly straightforward, like those rules for playing tic-tac-toe, for example. But unlike the tic-tac-toe rules, they're hard to actually, they're slow to run. This is a little bit trivial in the sense that you might have something like a very simply described search procedure that runs for a very long time. But in general, it results in a frame of thinking about what it means to be creative that sort of allows for a combination of cleverness, luck, and a variety of different strategies for search. Another thing that's a kind of a neat win is that this connects to our framework for novelty in the AIT frame, in that once you find a good member of a collection of objects, the AIT frame says nothing like what you've just built is at all good. Again, it goes to this idea of diversity as saying, if I've seen an object, I don't want to see anything near it anymore because that wouldn't be novel. And so this imagines also a way of looking for search strategies that are novel compared to what you've already seen so far. This is easy to describe in an AIT sense, And that's one of the sort of little wins of this paper. All of the things in this paper, and in fact, all of the things in this whole thread have one big problem, which is that every AIT calculation actually can't be done. The Kolmogorov complexity of an object is an uncomputable value, and that's sort of the baseline from which all of this work starts from. But on the other hand, something that we really like about this is that it gives the idea that search algorithms should be small, diversifying, and potentially slow. There are some things that come in the way of this, where you might think you found one of those, but actually you've done something a little sloppy. So you could look at the paper that Max and I had last year that gives some more information about that. Really, this is also an ad. I have been transformed in my creative practice by this work, and I invite you to be as well. This idea of applying algorithmic information theory to computational creativity makes me really happy, and I hope it does for you too. One last comment, which I think is kind of charming, but Dan mentioned to me this morning. One example of one of these small programs that encodes a lot of information is actually our short little 4-page paper. I invite you to read it.
More interesting questions? Okay, you guys, I'll start with you first.
You're appropriately, like self-deprecating about, the fundamental computability of Kolmogorov and all this stuff. But if you are willing to accept a certain sloppiness and substitute an imprecise compressor, then wouldn't you be able to apply this in the context of, let's say, text to image, looking at the compressibility of images when you've got other images, or images when you've got prompts, and do some practical stuff in that space?
If we sort of rewind away from this particular application, yes, that's true. One of the most satisfying things in this whole space actually is, and you can, I think this pops up in the second paper that Tiasimondo and I wrote about it, is also if you change the space of acceptable programs to something that is not every Turing machine, but something a little, or every Turing machine that halts even, but something noticeably more restrictive than that, then you can actually start to compute some of these quantities, or at least estimate them a little bit better. It's not 100% clear, but yeah, it's probably still there. Yeah.
Thanks.
Mm-hmm. That's simpler.
So I think this is getting really close to what I've been working for my PhD. So
I had noticed a certain similarity. Yes.
Yeah, the relationship, for example, what you define as searching for programs, like turning sequences into program. This is the definition of a scientist in formal learning theory. So my question is.
Ask your question.
Sorry.
I'll
Yes.
respond to both parts. Yeah.
So my question is, I've been thinking about this, like, so you're posing this, like, searching in this space for a certain kind of things is creative. So is there like a function from sequences to Turing machines that are functions from sequences to Turing, some of those functions that are creative and others that are not? Is that what you're...
that's really interesting.
So
yeah,
basically
some sort of inspiration model or something like that.
What I'm asking is that if you believe in functionalism, or in a sense, like if you can actually have creative functions and non-creative functions, the same way you have computable functions and non-computable functions.
Oof. I need to think about this some more. It's a great question. In general, one of the challenges, but also exciting areas with this frame is how models in this frame react to new information. And at the risk of going a little digression, but I promise it'll be short because I know I'm between you and lunch.
Yeah.
One of the things that's really fascinating about computers in this frame is that they don't forget. And one of the most interesting things about creative humans is how our forgetting lends us to be able to get into new spaces. And so I have been thinking a lot over several years now about trying to come up with good models for how to incorporate forgetting into this frame. And that's almost as important as incorporating new information, which does not answer your question, but tells you what I think about a lot, at least.
Okay. Yes, we can talk over
Absolutely,
lunch.
we
Yes.
can. I'm looking forward. All right. Thanks very much, everyone.
Thanks, Dan. Let's everyone. Let's also have a quick round of applause for all the speakers in this very interesting final session. And I see Maria stomping towards the stage determinedly. Are you writing slides now?
I am, yes.
There you go.
Cool. Garrett is also in the room. Excellent. Let me see if I can do. I would just like to use my screen for a second. So, first we have a few things to say before we start the slides. I was just finalizing. Thank you guys so much. It was really awesome to have so many people come from all over the world, old faces and new faces and young faces as well. Good. I hope you had fun and that you learned something. I always say that, but I don't know if I mean it anymore. It's like, if you enjoyed yourself, I think that's a good start. We had a great time. We are also doing, oh, no, we have to pause it because it's going out by itself. We pause it, don't worry, we pause it. It's gonna be fine. No. So complicated. Okay, let's, no. Okay, yeah, this is just a computer fighting with us. So first of all, sorry for not having any catering today because it's a national holiday and none of the restaurants wanted to offer us anything. So the coffee came from our machine, which I made this morning in a sort of a semi-creative way. And the cakes, of course, were the only thing we could get our hands on, which is, I think, quite nice. There's lots still there. So please have a little snack of cake before you leave. We also prepared a tiny little snack to get you going until the restaurant. Thank you, Gerd. It's a classic Swedish to-go sandwich on hard bread because we don't want you to have too much fun. I'm sorry, it's really sort of a last-minute situation there. And then we have two different kinds of what's it called? Like drinks, which are a little bit classic Swedish beverages. One is blueberry soup. That sounds really weird. And the other one is what is it called in English? Nyponsoppa, for those of you who speak Swedish. Yeah, what? Rose hip, it's true. It's rose hip soup. If you want to go for something a little bit wilder, you go for the rose hip soup. And if you want to go for something more standard, you go for the blueberry. You know, or you hope that somebody else went for the other one. That's essentially it. For the afternoon, there is a possibility to join us for casual midsummer hangout, because this is, of course, the reason why you are here. No, but we do have a special type of midsummer celebration in Sweden. And for people who want to come and have a look and take pictures of adult Swedish people or members of the community and making a fool out of themselves, this is a golden opportunity. There's a particular kind of dances and celebrations with music and stuff like that that is going to take place in Stadsparken. So we will be going from here approximately 2 to go over there. It's a perfect opportunity to bring some picnic, but you have to arrange for that yourself, or you can come and have already brought some. So this is very, very casual. Figure out your own group or join us if you want to. But that's what we will be doing, and anybody who wants to come can do that. No, we will go there. It's about 15 minutes. So we just walk. It's not far. Maybe. but there might also be a very long queue. So I would recommend to pop into one of the supermarkets and get some potato salad and some, I don't know, roast beef or vegan carrots or something. I don't know. I love carrots. Why are you laughing? It's great. Just as a sort of a backup, because it's not guaranteed that you will get food and drinks there. So if you want to have something with you, consider doing that before you come here, because we will not pass by anything. It's called Stadsparken, so it literally means city park. You can also meet us there if you want to. It's from this side seen. Let's see. So if you exit on the engineering side, then it will be on that side. So you just continue, and then it's up the hill. You see the flags. You follow the music, hopefully, and then you will find it. So it should be okay. It's quite big. And do we have anything more to say?
Thank you again to Maria, everyone.
This is gonna get to my head, guys. It's a dangerous development. Okay, so with no further ado, because the game wants to really play, we're gonna do two things. Sorry, I mean, this is a bit of a disaster. So yeah, this is for fun because I hate when everything just ends. So we are gonna go. Oh, music doesn't work. Shit. Ah. No. We're gonna start it again with music now. Random seconds on. Okay, thank you very much, and please leave. Oh, yes, by the way, sorry. We also have glasses from the welcome reception. If anybody did not take theirs and want one, I have dirty ones. So you can come pick up a random dirty one.